Hi everyone, welcome to Vedantu NEET English. I am Diksha Kaushal, your chemistry master teacher. So everybody, very good evening and welcome to this class. So I hope so. I am visible and audible to all of you present here, and I am very excited to start this revision because you will get totally handwritten notes, right? No PPT, nothing will be there, right? Totally blank slide, and I will teach you with my handwritten notes only, right? Everything will be provided on this channel only. So are you guys excited for your NEET preparation and revision series? Yes, everybody, are you all excited? Yes, let's go. And with an express, right, like an express, this is your NEET Express, which is going to land you on your medical college, at your medical college, right? And this journey is going to be really interesting. I know you want that destination, but the journey is also very important, right? So you will admire this journey throughout your life, that how you used to sit for 2-3 hours and in one shot you prepared that chapter along with the handwritten notes, right? So are you all excited? Yes, everybody. So if you're excited, then I want green hearts in the chat box. Everybody. Yes, everyone. Green hearts in the chat box for chemistry, for some basic concepts of chemistry. So now this chapter, so many of students, they find it difficult. Some of them find it easy. Some of them find it, okay, ma'am, this has no use. But ma'am, is this important or not? You will see this yourself. See, some basic concepts of chemistry, it has so many concepts that are directly applied in the other chapters as well, right? So if you don't know this chapter, you will find difficulty in other chapters as well. Second thing is, how many questions are asked from this chapter? 2 to 3 questions will be asked, right? And those 2 to 3 questions will not be complicated, very easy, simple, direct questions are asked from this chapter. Okay, so I'm so happy to see the energy in the chat box. I'm so happy and so excited. So, shall we start? Shall we start? Yes. Okay, shall we start the session? Okay, recorded class? Do you want recorded class, RSML? Why you want recorded class? Huh? When you can have the teacher in live session, you can ask your doubt, then why recorded? Huh? Chalo. Okay, then let us start it. Firstly, let us write down what we are going to start. And tomorrow, right, something really interesting is coming for all the NEET aspirants out there, right? And I'll just now keep quiet. But you will get to know that the link is in the description. Also in the live session, you will see a live that is going to happen tomorrow, right? So tomorrow you will get very interesting surprise that we are very excited to tell you. Okay? Yes. Now, let us start this class. Let us start this class. Now, starting with what we are going to study in this full chapter, right? We are going to complete this today only, right? So, I want the full power energy in the chat box, right? Throughout this session. So, first is you are going to study about the laws, right? Laws of combination. That is one, the topic. Laws of chemical combination. Then you have mole concept in your syllabus. You have mole concept, right? And this concept is applied everywhere throughout physical chemistry. Then you have, related to this, you have stoichiometry. You have stoichiometry, right? In stoichiometry, you have purity, percentage, basically percentage kind of questions. Percentage yield, percentage purity, these kind of questions, right? Percentage yield and percentage purity and percentage purity. And related to this, you also have one more thing, that is limiting reagent. That is limiting. I am going to tell you the tricks, okay? I am directly going to tell you the tricks, and even the long method, it will be totally your choice. If you want to adapt the tricks or you want to adapt the long method, that is totally your choice, right? Next thing is empirical formula. Empirical, these are the important topics, okay? Empirical formula, right? How to calculate empirical formula, molecular formula. Then last one is concentration terms. That is also used in 12th chapter, that is solution, right? So concentration terms. So these are the topics that we are going to study in this chapter, right? These 1, 2, 3, 4, 5, 6, 7, 8. 8 topics we are going to study in today's class and in this chapter. Okay? Yes, everybody. So basically, this is the first chapter of chemistry. So here, I will do everything in a very crisp and in a very short manner, but in a detailed manner, because everything will be counted in that. Everything I will teach you, but in a very crisp manner that will be useful for your NEET exam, because here the thought is to crack NEET exam, right? That is our target. So based on that target only I am going to teach you, right? So first thing that we are going to talk about is a very basic thing, right? In first 15 minutes, we are going to talk about some basics, right? The basics are, firstly, you have the matter, right? Firstly, you have matter. So what is matter and how it is classified? So basically, guys, the matter is classified into two parts, right? There are two classifications of matter. First is physical classification, then you have chemical classification, Based on physical classification, you have three things. One is solid, then you have liquid, then you have gas, Solid, liquid, gas you also have done in your lower classes, but now let us see what exactly is the solid, liquid, gas. So there are two factors that determine whether it will be a solid or it will be a liquid or it will be a gas. So can you tell me what are these two factors? These two factors are intermolecular forces of attraction, right? How molecules want to stay together, right? But next, the second important point is thermal energy. Thermal energy is that molecules want to stay away from each other, right? Very, very away from each other. So if you say that here in the solids, you have strong intermolecular forces. So I'm just writing here forces of attraction. They are stronger as compared to thermal energy. TE is the thermal energy. But when we talk about liquid, they are intermediate with each other. Forces of attraction are approximately intermediate with the thermal energy. If you talk about gaseous state, can you tell me which will be larger? Solid are very compact, they are very close to each other. Liquid are little bit far away. Gases are really, really far away from each other. So in gases, forces of attraction is not very strong, right? Which is strong? Thermal energy or forces of attraction? In gases, which is strong? See, very simple thing. You want to stay away from each other. You don't like your friend. What you will do? You will say, get out of my life. Yeah? It will be very like you don't have forces of attraction with them. That's why you want to stay away from them. So that means the forces of attraction are going to be very less as compared to thermal energy, right? So that is how we determine that this is a not sinking, bit lagging. Guys, just please adjust for today, right? For your Diksha Ma'am, adjust for today. I don't know what is the issue with this OBS, right? I have called up the studio team at my home only, right? The engineer is coming tomorrow at my home because I was not able to resolve it myself. One option was that I should not take this class today, but I really wanted to take this class today because I feel that I should not cancel the class because of some studio issues, right? So I hope so you guys will adjust with this one. Okay? Yes? Will everybody adjust with this one? Yes? Hana? It's not that much problem, right? Okay? Yes. So everybody, for my motivation, I want green hearts in the chat box, right? Okay? Yes. Now, this is forces of attraction are very less as compared to thermal energy, right? Okay, so this is how we classify on the basis of physical classification, solid, liquid and gases. Now, if you talk about chemical classification is based on which thing? Chemical classification is based on which thing? Everybody in the chat box, chemical classification is based on two things, right? That is, we say that one is pure substances, other is mixtures. What is pure substances? What are pure substances? Pure substances means they have actually a proportionate value. That means you can say that there is constant proportion. You can say if H2O has 2 hydrogen and 1 oxygen only. That means a definite proportion of atoms you have in pure things, right? But if you talk about mixture, there is not any definite proportion that you should have carbon and oxygen in this proportion. For example, CO2, right? We know that carbon and oxygen should be in this much proportion. But if you talk about water and milk, right, you are mixing them together, you don't need to have like a proper definite proportion, like how much amount you need to have, right? So these are called mixture. So if you talk about the pure compounds, they are also divided into two parts. One is elements, other is compounds. So what are these elements? Elements are hydrogen, helium, right? Or you can say sodium, right? Which is just one atom, which has just one atom. Copper, right? It has copper atoms. Aluminium, it has aluminium atoms. And what are compounds? Compounds are basically like H2O, CO2, right? CO2. Wait a minute. Like CO2, like HCl. These are the compounds that we have. But here we have the fixed proportion. Mixtures are also of two types. What are these two types? One is homogeneous, other is heterogeneous. Okay. Can you tell me what is a homogeneous mixture? For example, you all are in one uniform thing, right? When you go to school, that everyone has the same uniform. That is homogeneous mixture. So, for example, you are adding sugar into the water. Sugar is mixed into the water in a very like proportionate manner. We don't see that in one spoon you have more sugar, in next spoon you have less sugar. But when you add soil into the water, soil is settled, right? And the water is upwards, the soil is downwards, settled, right, in the bottom. So here we say that in the bottom you have more soil, but upwards, right, you have less soil. So there you can say that in heterogeneous you don't have not uniform proportion, not uniform. The mixture is not uniform, but in homogeneous the mixture is uniform. So guys, you can take a screenshot of this also. This is your total classification of a matter, right? This is full-fledged classification of a matter, right? You can take a screenshot here. You will also get the PDF, right? Now, second thing is, matter is made up of which thing? Can you tell me matter is made up of which thing? Matter is made up of atoms, and matter is basically made up of tiny particles. And what are these tiny particles? These tiny particles are nothing but these can be atoms or these can be molecules, right? These tiny particles can be atoms or these can be molecules. So if you talk about that these tiny particles in which this matter is made up of, the solid, the liquid, the gases, they are made up of these tiny particles. They are called atoms or molecules. So what are exactly these atoms, right? What are exactly these atoms? So for example, I talk about hydrogen atom. I talk about a carbon atom. There is one single atom that is present here. In a molecule, you have two atoms, right? Okay. That means even these molecules are divided into two things. That is homoatomic and heteroatomic. Right? Heteroatomic. So if you talk about homoatomic, that means if it has two atoms, it is diatomic, then the number of the atoms are same only. If you talk about H2, O2, right? H2, or you talk about O2, or you talk about N2. Now in H2 also you have two hydrogen atoms. In O2 also you have two oxygen atoms. That means you have same atoms. That is why it is called homoatomic. Homo means same kind of thing. Hetero means different kind of things, right? So here you have maybe two or three different kind of atoms in a molecule. Like for example, you have H2O. For example, you have NaCl. For example, you have HNO3, right? So it is having three atoms. It is having three kind of atoms. It is having two kind of atoms. It is having two kind of atoms. So that is the classification of how matter is made up of tiny particles, right? Okay, is this thing clear to everybody? Right? I hope so. Now you have a very good revision and recap of what we have studied, right? Now, slowly and surely, we are going to deep dive into this chapter, right? So be careful of every single line that I am telling you today, right? So I'll just say something and you will have one trick. Okay. So I'm going from basic to complexity level, basic to complex. Okay. So now here, next part is we will discuss about these atoms in details. Right. Okay. So let us talk about firstly the representation, or let us talk about the atomicity. So little things I am going to tell you. Atomicity. What is atomicity? Atomicity is the number of atoms in that molecule. Now, if I talk about a glucose molecule, a compound C6H12O6, right? What is the atomicity? Anybody in the chat box? The overall atomicity of this molecule is 12 plus 6 plus 6, that is 24 atoms, right? So atomicity is 24. Atomicity is 24. Now if you talk about atomicity of carbon, how many carbon atoms? Total atomicity is 24. But how many carbon atoms you have? You have only 6 carbon atoms. Atomicity of hydrogen. Atomicity of oxygen. Now everybody in the chat box, what is the atomicity of hydrogen? How many hydrogen atoms you can see here? Hydrogen atom is how many? Everybody, very good. 12, right? That is 12. How many oxygen atoms you have? Very good. Oxygen atom is 6. So you need to see what exactly they are telling you, right? Which atomicity they are asking you for a particular element in that compound, or overall atomicity they are asking you. So it generally saying that atomicity will be defined as, or you can say molecule is equals to atomicity into atoms. For example, I have H2 molecule. In this, what is the atomicity? Molecule is H2. It is 2 into hydrogen. So this is the molecule. This is 2 into hydrogen. Hydrogen is the atom and atomicity is 2. That is why the molecule will become H2. If you talk about O3, so here atomicity is 3 and the atom is oxygen. If you talk about N2, atomicity is 2 and the atom is nitrogen. That is why it is becoming N2. So overall we can say that molecule is equals to atomicity into atoms. So these are the things that will be useful when we will apply stoichiometry, mole concept, limiting reagent. These 3 things are based on the basics that I am going to tell you in next 15 minutes. Right? Okay everybody. Now let us see the representation. Let us see the representation. Anybody in the chat box? Now, let us see how many of you remember this, right? It's like this. This is A, this is X, and this is Z. Now, what exactly is this A? What is this Z? And what is this X? This is the representation of an atom, right? Now, X is called as the element, whichever element you are talking about. Not specifically, don't say ma'am X means halogen. No beta, this is generally I am telling you a general way of representing, right? Now what is this A and what is this Z? Let us see how many of you remember this thing, right? What is this A? Yes, this is one shot. I am going to complete this chapter. We are going to finish this chapter along with the questions today itself, right? Along with the questions, the kind of questions, and trust me on that, the questions that I'll teach you today, these kind of question only you will see in your exam. I can guarantee you for that, right? So A is the mass, A is the atomic mass, you can say, or you can say the mass number. A is the, not atomic mass, it is the mass number, right? So it is number of proton plus number of neutron. Okay, what do you mean by Z? Z is the atomic number. And atomic number is equals to number of protons. Can you tell me why mass number does not include electrons, because the mass of the electron is very, very small as compared to proton and neutron. That is why while calculating the mass of the overall atom, we take just the nucleus. And in the nucleus, you have protons and neutrons. Outside, electrons are revolving around it. Right? So atomic number, that explains the number of protons. And also one more thing, for a neutral atom, you can write one thing, that number of proton is equals to number of electron. For a neutral atom, number of proton is equals to number of electron. Okay guys, for a neutral atom, number of proton is equals to number of electron. So, one more thing, let us see. We have talked about that what is a electron, proton and all of these things, right, where this exists. But you also need to know one more thing, that if you talk about electron, proton and neutron, first thing you need to know is their charge, then their relative charge, then their mass, then their relative mass. Okay. So let us make a table here, right? And this table you need to remember, right? Here I am talking about the electrons, protons. So let us write electrons here, right? These are the protons, and here I am writing neutrons. And here I am writing neutrons. Here we will write the charge. Here we will write the charge, right? This is the relative charge, right? This is the mass, absolute mass, okay? This is the absolute mass, like the exact mass that it has. And this is the relative mass. This is the relative mass. Now, let us see how many of you actually remember these things. Let us see how many of you remember these things. Okay, guys? Now, electrons has a negative charge, right? Okay? Okay? Yes, everybody. Electrons has which kind of mass? What is the mass? What is the mass? What is the mass? Minus 1.6 into 10 raised per minus 19 coulomb. Right, that is the mass. Right, okay. Guys, you tell me what you want. Should I end the lecture today? Right, should I end the lecture today? Explain you in some other day. If you find that the problem is too much for you, then I can just end this class today and we can take the class someday else, maybe some other day, right? But if you want that, no, this is the absolute charge. If you can adjust today, so this problem will be sorted tomorrow. See, I am not an engineer, right? I need an engineer to sort out this problem, right? And this will be sorted out by tomorrow, right? Okay? Yes. So you guys can adjust, right? So that totally, because I didn't wanted to waste some time because of a little glitch, right? Okay. So a glitch should not be the problem in between us, right? Okay. Yes. Now the mass, the charge on the proton is 1.6 into 10 raised per minus 19 coulomb. What is the neutrons? Neutron has zero charge. So it will be 0. It is going to be 0. Okay. What about the relative charge? Now, if I say the relative charge of the electron is taken as -1, it is taken as +1, and it is taken as 0. Right? And it is taken as 0. Okay. Yes, everybody. Yes, everybody. Yes, everybody. Yes. Now, you need to tell me the absolute mass, whatever you can tell me, either in kilogram or gram. Yes, everybody? Okay, just give me a minute. I think now that's better. Yes. Yes. Can you now tell me what is the absolute mass? The absolute mass is 9.1, everybody in the chat box, that is 9.1 into 10 raised per minus 31 kilogram, right? Okay, then you have 1.6 into 10 raised per minus 27 kilogram, right? Then this is also 1.6 into 10 raised per minus 27 kilogram, right? Okay, Yes? Okay, everybody? Yes, everybody? Very good, very good, very good. Right? So that is your absolute mass. Now, if you want to write the relative mass is taken in unity. Right? This is taken as, for example, this is approximately taken as 0 only. Right? It is approximately taken as 0 only, negligible, because in front of minus 27, minus 31 is very small. Right? This is taken as 1 and this is also taken as 1. Okay? Yes. Now, here we are talking about protons, right? These are basically unit things only. That is why we will take it as 1 atomic mass unit. I'll tell you what is this atomic mass unit. Okay, I'll tell you what is this. Basically, it is a reciprocal of Avogadro's number. That is your atomic mass unit, right? Okay. Yes, everybody. Is this thing clear to everyone or not? Is this thing clear to everyone or not? Yes, everyone. Is this thing clear to you? Yes, everybody. Now, tell me one thing. If they ask you the mass of proton, neutron and electron, which is large? So, what you need to know? The mass of neutron is the maximum. Then you have, or you can even write it as mass of neutron here. Mass of neutron is maximum. Then you have mass of proton, and mass of electron is very, very small as compared to mass of neutron and proton, right? And this is also approximately same only. Neutron and proton are taken as approximately same only. If you talk about these two things, these are the approximate values. Approximately they are taken as same, right? Okay, but if they ask you specially that out of neutron and proton which has more mass, then neutron will have slightly more mass as compared to protons, right? Okay, now I told you one thing, that let us talk about cations and let us talk about anions, right? And let us talk about anions. If you talk about cations, cations are made by, I told you one thing here, that was for a neutral atom. Now, if the atom is not neutral, either it can be a cation or it can be a anion. Any of these things, right? Either it can be a cation or it can be a anion. So, if it is a cation, that means it is formed by loss of electron. It is positive, right? It is positive, anion is negative. Here you have loss of electron, and here you have gain of electron. Here you have gain of electron, right? So now, if we want to see that here in the cations, what happens, that there is one, firstly, let us see the one more relation here. After that, I'll come to this again, right? After that, I'll come to this again. Now, let us calculate the mass of one atom. Mass of an atom. One atom you can write. Mass of one atom. I told you if you want to calculate the mass of a single atom, right, you need to see the number of neutrons and protons, right? So that will be number of neutrons and number of protons. So that means, right, mass of one neutron, you can say mass of one neutron multiplied by number of neutron plus mass of one proton multiplied by number of proton, right? So if you have 7 neutrons, that will be 7 into mass of neutron, right? But we know that mass of neutron and protons are equal to each other. So can I write it as number of neutrons, n of number of neutrons plus mass of neutron into number of proton, right? Anything you can write. Number of neutron you can take common, that will be number of neutron plus number of proton, right? Now tell me one thing, number of neutron and number of proton, I told you one thing here, that number of neutron plus number of proton is equals to mass number, right? So I am going to tell you a very important thing here, that if you multiply, this will be equals to mass of neutron and this is mass number. This is mass number, right? Now, you can say that mass of one atom is equals to mass of proton or mass of neutron multiplied by mass number, mass number. Can you see this thing? Can you see this thing? Right? That is equals to mass of proton or mass of neutron multiplied by mass number. Right? So, from this, I can say one more thing, that mass of, very, very important, mass of one atom is equals to, you know what is mass of proton and mass of neutron? What is mass of neutron and mass of proton? 1.6 into 10 raised to power minus 27, right? So can I write this exact mass here? 1.6 into 10 raised to power minus 27 gram multiplied by mass number, right? Now guys, this thing is nothing but this is 1 AMU only, right? This is called 1 AMU that I was telling you, that I will tell you in detail. So now we can write that mass of one atom, any atom you talk about, that will be equals to mass number of that atom, multiplied by, or you can say not even multiplied, you can just write mass number AMU. AMU is the new unit for your atoms, right? So here, if we talk about, for example, for oxygen atom you want to calculate. Now, what is the number of protons and neutrons in oxygen atom? Right? That is, what is the mass of protons and neutrons in oxygen atom? That is 16, right? So 16 is the mass number, and AMU you can write here, right? Or it is also called simply U. You can also write simply U. If you talk about nitrogen atom, the mass of neutrons and protons. Neutrons is also 7, protons is also 7, right? Now, what is the number of neutrons plus protons in nitrogen is 14, so that will be 14 AMU, right? Okay, understood this thing? How we today know that just calculate the number of neutrons and protons and we write here AMU. This is how we write AMU here, right? Okay, this is how we write AMU. Now I'm going to tell you a very important thing that students are usually confused about. They'll like they understand, or like, ma'am, we understand organic chemistry, inorganic chemistry, all the difficult reaction we understand. But ma'am, we don't know what is this gram per mole, ma'am, what is this AMU, where to write AMU, where to write this. What is the difference, ma'am? So let us see the difference here. See, for example, they have asked you, I'll tell you just few things here. Now, for example, they are asking you mass of one atom, right? That will be equals to dash into AMU, right? For example, it is X AMU. For any atom, let's say X atom, that is X into AMU. X is the mass number. Or I can just write the mass number as A. A is the mass number. We denote A as the mass number, right? So, mass of 1 mole of that atom. 1 mole means 6.022 into 10 raised to power 23, right? That means 6.022 into 10 raised to power 23, that is the mass, that is the 1 mole, right? So you can write here mass number, mass number multiplied by gram, right? Mass number multiplied by gram. Now this thing is same, the numeric value is same for even one atom or 1 mole. It's just the difference in the units here, right? It's the difference in the units here. It is also called gram per mole because we are writing it for mole, or it is also called, you can just simply say A gram, right? That will be same, right? Okay. Now, I'm going to tell you a few things here. Now, if you want to write mass of oxygen atom, right? Mass of 1 mole of oxygen atom, right? Then you have mass of 1 molecule, of oxygen, right? Then you have mass of 1 mole of O2, right? Okay. Now let us see how they are different from each other, right? Okay, let us see how they are different from each other. Okay, mass of oxygen atom, that is 16, that is the mass number, multiplied by AMU, that is atomic mass unit, or it is also called 16U, right? Mass of 1 mole, that means the numeric value is going to get the same only. There is difference in the units. So here you will write gram, right? Numeric value will be same. Mass of 1 mole of O2. O2 means 2 oxygen atoms. So this 16 will be multiplied by 2. That will become 32. So you'll write 32, but it is for 1 molecule. Here you will not write AMU because AMU is for atomic mass unit. Though the unit is same only because we all talk about molecules, so instead AMU we will simply write U, right? That is why instead of AMU we are writing U sometimes, right? Okay. Mass of 1 mole of O2. That means now this thing will be multiplied by 6.0. See, I'll tell you one simple thing why it is so. Okay, tell me one thing. What is this U? What is this U? This is nothing but AMU only. What is the value of AMU? That is 1.6 into 10 raised to power minus 27, right? Now, we are talking about 1 mole and this is 6.022 into 10 raised to power 23. Now, this is gram only. This is the value of AMU. We know that AMU is 1.6 into 10 raised to power minus 27 grams. These two are reciprocal of each other. They will cancel out each other. It will become 32 gram. That is why I am saying that the difference in 1 mole and 1 atom is gram, and units will change. Numeric value will stay the same. Right? Okay. Because reason you can write here that Avogadro's number is a reciprocal of atomic mass unit, right? Okay, that means 6.022 into 10 raised to power 23, right? It is a reciprocal of 1.67 into 10 raised to power 20 minus 27, right? That is why they will cancel out each other and will become 1. Okay, understood this thing? You can use the calculator as well. You will get the same thing. That is the reason these two will cancel out each other and the numeric value will remain the same. Okay, guys, is this clear to everybody here or not? Is this clear to everybody here or not? Is this clear? Yes, students, is there any problem what we have done till now? Is there any problem what we have done till now? Yes. Now, let us see the cations here, right? As I told you, the cation is loss of electron, right? So, if you want to calculate the mass number here, mass number, we know that mass number is equals to neutron plus protons, right? Okay, so now you need to tell me, mass number, I am saying number of electrons. Number of electrons. I know it's a very simple thing, but some of you like find it difficult, right? So, number of electrons. Number of electrons is the protons you had minus, here you are losing the electron, minus the charge, that means the number of electron lost. But in the case of anions, that is number of protons plus you will add the charge, right? For example, here you had M3 positive. Here 3 will be subtracted because 3 electrons are lost, right? But in this case, if you have M3 negative, in this case 3 electrons will be added because it is gaining 3 electrons, right? Because it is gaining 3 electrons, right? In that way, the total mass number will not vary, but number of electrons will vary here, right? Okay, mass number will not vary. Okay, guys, understood? Now, let us see the next part of this thing. This also we have done. Now, let us see the cation. I think yes. Now, let us see the isotopes, right? So, there are 6 kind of iso species that you have. From anywhere they can ask you the question. Most important is isotopes. Most important is isotopes. So, what exactly are isotopes? Anybody in the chat box? Isotopes like carbon 12, carbon 13, carbon 14, right? So, isotopes, what they will have, this mass number will change, right? Number of protons are same only, but the mass number will change, right? So you can write one thing, the same mass number, same atomic number, but different mass number, right? Okay, so here, now if atomic number is same, that means protons are same, right? Mass number is different, that means number of protons plus neutrons are different, right? Number of protons plus neutrons are different. Now tell me one thing, if I am saying that your number of proton is same, here it is same, that means here also it will be same. That means in this case, exactly, neutrons are different. Because this, so we have said, na, number of protons is same only. So that means another definition can be same number of protons, but different neutrons. Right? Okay. Yes, everybody. Yes, everybody. I can't see your chats. Just give me a second. Yes, everyone. Yes. Now, they can also ask you one more thing related to this. That which is same here, chemical or physical property. See, because the core is same, protons is same. That is why chemical properties are same. Same chemical properties, but different physical properties, right? But different physical properties. This question also has been asked, right? Okay, example they can ask you. Example is like carbon 12, carbon 13, carbon 14, right? Okay, that is the example. All of these has 6 protons, but the neutrons are different here. Hydrogen has 3 isotopes, right? Deuterium, tritium, right? These are having 3 isotopes. Oxygen have oxygen 16, oxygen 18, right? So based on this, we have different examples here, right? Okay. Now, we know that here the mass is different. What I am telling you here, same atomic number, different mass number. That means mass number is different. If mass number is different, that means mass is also different, right? So here we have one concept of average atomic mass, from where also easy questions can be asked. Average atomic mass. So what is exactly this average atomic mass? That is the summation of the abundance, that means in how much percent you have that isotope, multiplied by the mass of that isotope, multiplied by the mass of that isotope, right? That is going to be your average atomic mass, and divided by the total, right? Right? Okay, everybody. Sorry, divided by 100. Now I am giving you one example. Let's take an example that you have some X atom which is having maybe 2 isotopes, right? So I am saying this is 25%, this is 75%. Here it is X and this is Y, right? So here the average atomic mass will be equals to 25 into X, 75 multiplied by Y divided by 100. Right? Because out of 100 we are calculating that thing. So that is going to be your average atomic mass here. This is the example that I am telling you. Right? So there are so many questions based on this. Right? They will give you 3 isotopes, 4 isotopes also they can give you. Maximum they will give you 3 isotopes only. Right? And you can write also one more thing here, that in these kind of questions in isotopes, the heavier isotope is a radioactive element. Usually it is a radioactive element. The heavier, usually I am not saying always, the heavier isotope is a usually radioactive element. So these were the things about isotopes, okay? Now let us talk about isobars. Isobars are opposite of isotopes. Just just the exact opposite definition it will have. Example, this I have given you example 12, 13, 14, right? Okay, yes. Now next is isobars. I'll give you all the examples in the end of this lecture, right? Okay, we are going to practice that, right? So isobars, if you talk about the isobars here, wait a minute, give me 5 minutes. After completing this, I'll give you one question based on this, okay? So isobars are basically, if you talk about here, we said that it had same atomic number, different mass number. It will be opposite. Same mass number, different atomic number, right? Same mass number, but different atomic number. That is going to be the definition of isobars here, right? Okay, same mass number means you have same nucleus. Nucleus means number of neutrons plus protons is going to be same. Same number of neutrons plus number of protons, but number of protons, this together will be same, but number of protons will be different. But different protons. Protons are different, but if you add neutrons into it, then it will be same, right? Okay. Now, next is isobars also. Then you have isotones. Then you have third one is isotones. So, do you know what is an isotone? Anybody in the chat box, what is an isotone? Anybody in the chat box, what is an isotone? Anybody in the chat box? Yes, isotones. It has same number of neutrons. If it has same number of neutrons, that is called as N for isotones. Here you have N, right? From here you can understand N means neutrons, right? Then next one is isoelectronic. Next is isosters and isodiaphers. And isosters. So what is isoelectronic? Which has same number of electrons. That is called isoelectronic, right? Okay. Okay, everybody. Now, what is this isosters? That is same number of, it is quite similar to isoelectronic only, but here the important thing is number of electrons and atomicity. And atomicity is also same. It has the same number of electrons and the atomicity is also the same here, right? If you talk about isodiaphers, in this case, the number of neutrons minus number of protons. Number of neutrons minus number of protons. That means N minus P, that is same. N minus P, that is going to be same, right? That is going to be same. Okay. Yes, everyone, that is going to be the definition of isobars, isotones, isoelectronic, isodiaphers, isosters. They will give you two examples. Out of this, they will give you the example in the form of this kind of representation, right? This kind of representation, they will give you the example, right? Okay, this kind of representation, they will give you the example. From there, you will tell that whether it is isotones, isosters, isodiaphers. Usually, they will ask you isotones only. Maximum they can ask you the properties of isotone, isobars. Isoelectronic is their favorite topic, right? But isodiaphers and isosters can also be asked to you, right? Okay. Okay, guys. Okay. Let us see what is the next topic. Yes. Now, I think we have done atoms also, we have done isobars, isoelectronic, these also. Now let us start with the mole concept, okay? Yes, let us start with the mole concept, okay? Yes, mole concept. Okay, I told you, I'll give you one question. Yeah, I thought I was forgetting something, right? Just give me a second. Okay, I'm going to give you one question here, very, very important question, right? This question is directly from your N Avasthi, right? Average atomic mass. I'll give you example that what kind of question they can give you. Average atomic mass of magnesium is, right? Average atomic mass of magnesium is 24.3 AMU, right? AMU. Then they are asking you the magnesium is composed of 79%. Now I'm giving you directly what they are telling you, right? Mg24, this isotope is 79%, right? Then they have given that remaining 21% is Mg25 and Mg26, magnesium 26. They are together 21%, right? Now they are asking you to calculate the percentage of Mg. You need to calculate the percentage of Mg, right? This you need to calculate. Yes, everybody, this you need to calculate the percentage of Mg here. Okay, understood the question, right? So this is a good question from this topic, right? I am not giving you as a bakwas question, right? This is a good question, right? Because here there are chances that students can do mistakes, right? So from here you can see Mg24 is 79%. That means this together is 21%. If I take this as X, because they are asking me the percentage of this Mg26, and this will be 21 minus X. This is the important point here. If this is X, this will be 21 minus X, right? Okay, X 21 minus X. Now, the percentage they are saying is the average atomic mass of magnesium is 24.3, right? So, if the average atomic mass is 24.3, average atomic mass is equals to abundance of 24, abundance is 79%, plus this is 25 into 21 minus, this is 25 into 21 minus X, 21 minus X. And this is going to be X into 26. This is 26 into abundance of this one divided by 100. From here, doing the calculation, you just need to calculate the value of X. That will be your answer for the abundance of Mg26. If they ask you the abundance of this one, I'll take this as X and this as 21 minus X. Right? Understood or not? Everybody in the chat box? Everybody in the chat box, are you able to understand that what kind of questions they can ask you from average atomic masses? Right? Okay. Yes, everybody. Yes, everybody. Okay, shall I move with the next part? That is mole concept. Right? For mole concept, I'll give you 2-3 kind of questions. Trust me on that. Those kind of questions are repeatedly asked in NEET. Right? Okay. So now, mole concept, firstly you need to understand that what is mole concept. For that you need to understand what is this mole. So what is mole? Mole, as I told you, mole is basically when we talk about a specific number of particles, that is 6.022 into 10 raised to power 23 particles. I am not mentioning that this will be atoms or this will be molecules. I am saying that this will be this much particles. It can be atoms, it can be molecules, anything it can be, right? Now, second thing is, if 6.022 into 10 raised to power 23 particles, then you need to know one more thing here. That is, this number is called Avogadro's number. Just like we know that 12 bananas means 1 dozen. Right, we have specified that number. Similarly, 1 mole, we have specified that it is 6.022 into 10 raised to power 23 particles. Right, now, if you talk about the mole concept, we will define that mole in 3 ways. How we can calculate the number of moles? In 3 ways we can calculate the number of moles. What are these 3 ways? In 3 ways we can calculate the number of moles. What are these 3 ways? First is on the basis of mass, second is on the basis of particles, third is on the basis of volume. So now this mole concept, it is so important that your mole concept, stoichiometry or stoichiometry, some people pronounce it like stoichiometry, some stoichiometry, right? And limiting reagent, even the empirical formula, percentage purity, they all are dependent on this particular mole concept. If you're not able to understand this thing, then trust me on that, you will not be able to understand what I'm going to teach you in next 2 hours, right? That is not possible. So try to understand this thing. First, we are going to talk about the mass. So it will be equals to given mass by given, always it will be by given by molar. Always remember given by molar. Here you can write given by molar. Here also it is given by molar. Given by molar. Always it will be given by molar. Right? That is, first we are going to talk about given, then for 1 mole. Right? And it is also given by molar. Given by molar. When you talk about mass, it will be given mass by molar mass. Right? What is the mass of 1 mole? If you talk about the particles, it is given particles by molar particles, by molar particles. If you talk about volume, that is equals to given volume by molar volume, right? Now tell me, as I told you here, 1 mole have 6.022 into 10 raised to power 23 particles, which is regarded as Na. This is denoted by Na. So instead of writing molar particles, can we just simply write Na? Can we just simply write here Na? Because what is given particles? Sorry. What is 1 mole particles? What is the number of 1 mole particles? How many particles are there in 1 mole? 6.022 into 10 raised to power 23. That is Avogadro's number. Right, now you tell me what is molar volume. For molar volume, right, just write molar volume only. Just write molar volume only. I will tell you what is molar volume in detail. Right, because molar volume is also now like not tricky, but I would say a different kind of question can be asked on this, right? So there are 3 ways, right? First is you have 273 Kelvin, 273 Kelvin, then you have 298 Kelvin. 273 Kelvin, 0 degrees Celsius. 298 Kelvin means you will have 25 degrees Celsius. That is our room temperature, a general room temperature, right? Now, if the pressure is 1 atmospheric, if the pressure is 1 atmospheric, if the pressure is 1 baric, if the pressure is 1 baric. Now, this is 22.4, this is 22.7, I think this is 24.8. Wait a minute, let me check. Yes, this is 24.8. 24.8, yes. 24.8 and this is in liters, right? This is in liters, right? Okay. Now, if they specify, now listen to this thing very carefully. If they specify this thing, if it is specially given in the question that the standard STP, this is STP, standard temperature pressure. Now, if temperature is specially specified to be 25 degrees Celsius, it is specially written as 1 baric, then you will take 24.8. Otherwise, don't take 24.8. This is hardly used. If they are specially specified that it is 1 baric, right, pressure is 1 bar, then write 22.7. Otherwise, if nothing is mentioned to you, then you will take 22.4 only. That is highly used, right? If nothing is mentioned, the answer will be 22.4 only, right? Okay, yes guys, that will be 22.4 only. Now, this is your mole concept, and based on mole concept, let us do some questions, okay? Yes, based on mole concept, let us do some questions. Okay, give me a second. Let me see some questions here. Okay, now these are the questions, right? Okay, now these are the questions based on mole concept, because mole concept could be understood by questions only. So the first question is number of atoms in 7 gram of potassium is, in 7 gram of potassium is. Number of atoms in 7 gram of potassium. Everybody, number of atoms in 7 gram of potassium. Now, always remember the root is moles. Root is moles. That means whenever you want, it's like you have your mother and father, right? Whenever you want to go on any trip or something, what you will say? The medium is your mother, right? If you want to talk to your father, if you want to take permission, you always go to your mom and tell them the whole story. You will just butter your mother, right? After that, they will, like, okay, mother, empathy, sympathy towards their kid, right? Love for a kid, right? Then they will talk to the father. Isn't it the case? You'll always go to your mummy, right? So now this is your moles is mummy. Moles is our mothers. So we will always go to these moles and always we will ask them and we will get the answer. Always and always, always, moles are your mummy. Okay, moles are our mummy. Now, number of atoms, 7 gram of potassium. Right, students? So now firstly, let us calculate the moles here. Moles is 7 gram given mass by, what formula I am going to write here? Given mass by molar mass. Given mass by molar mass. Given mass is 7. Molar mass is 40. Right, so that is my moles. That is my number of moles. They are asking me to calculate the number of atoms here. So number of atoms, then I can calculate this by moles is equals to number of particles. Now here is atoms. Now particles are atoms divided by Avogadro's number. So atoms will be equals to number of moles, that is 7 by 40 multiplied by Avogadro's number. That is going to be your answer. Okay, that is going to be your answer. Understood? That is going to be your answer. So simply always and always go through mummy and then talk to papa. Right? So always firstly moles is the medium for everything. That is why we say mole concept. Why it is written as mole concept? So always the root is mummy. Right? So this is your mummy. Whenever you want to calculate volume, they can ask you, see, 3 things they can ask you. Either they can ask you given volume, or they can ask you given particles, or they can ask you given mass. Right? So always you will calculate moles. From that you can calculate particles. Particles are given, volume is asked, calculate moles and then go to volume. They are asking you mass and volume is given, calculate moles and then calculate the mass. Right? Okay, clear everybody? Clear? Yes, it is 1.5 into 10 raised power minus 23. Very good. 10 raised power minus 23. Okay. So you can just calculate this 6.022 into 10 raised power 23 multiplied by 7. This is 40. 7 42. Yes. So it is approximately 42 divided by 40 multiplied by 10 raised by 23. Yes, approximately it will be 1 point something, right? 1 point something into 10 raised by 23, not minus 23. 10 raised by 23, okay? 10 raised by 23, okay? Yes. Now, next thing is one more question, and mark it a very, very important question. Mark it very, 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 very important question. Trust me on that. These kind of questions are frequently asked, right? Okay. Now, I'm going to write this question over here, right? I'm going to write this question over here. Wait a minute. How many moles of HNO3, I don't know why here it is written HNO4. It should be HNO3, but they have written HNO4 in the solution. Solution contain 0.5 mole of 0.5 mole of oxygen atoms. 0.5 mole of oxygen atoms. Right? This they are asking you. Now, here they are not asking about one thing. So, here is one relation. I think here should be HNO3 only. Why are written HNO4? HNO3 only it should be. Right? Okay. So, now see one thing here. Right? See one thing here. You have HNO3. In this, they are asking you about oxygen. So, understand one thing very, very carefully. Very, very carefully understand one thing here. Always and always you are going to apply the same thing in stoichiometry. I will give you one trick also for that. See students, very important thing I am going to tell you here. For example, one thing will be asked to you, right? Always use this thing. One thing will be asked to you and one thing will be given to you, right? Whatever is given to you, whatever is given, always write this flowchart. Don't spam storyteller in the chat box. Don't spam. It's a very important thing for NEET aspirants. Don't do this here. Now, given, what is given to you, you will calculate the moles from the given thing. Whatever is given to me. They have given me a hint is given for oxygen, hint is given for atom, hint is given for a molecule, whatever is given to me. What is given to you, calculate the moles of that thing, then use unitary method, then calculate the moles of the one they are asking, the one molecule or element they are asking. Then from here, they can ask you either volume, from moles we can calculate volume, we can calculate particles, we can calculate volume, we can calculate mass, we can calculate particles. Here also they can give you volume, they can give you mass, they can give you particles, right? They can give you particles, right? Here you will calculate moles, then use unitary method, go and you can even calculate volume or mass or particles here. Anything you can calculate from here. So this is the overall trick and this is the overall chart you can say that you should follow, right? This is the overall chart that you should follow everywhere, right? Trust me on that, on solving so many questions and knowing that students get confused in these things because they don't have anything, they don't have, they don't have that much because in electrochemistry, in solution, colligative properties, you have formulas. You can just cram that formula and apply that formula. And in this chapter, you don't have that many formulas, right? Here you have these kind of concepts, these kind of steps that you need to follow, right? So with the same step, I am going to solve this particular question here in front of you, right? So let us solve this question here. Let us solve this question using the same steps here. So what is our first step? First, you need to see what is given to you. So, given is contains 0.5 mole of oxygen atom. They have given you moles only. So, this is given to you. This is given to you and this thing they are asking you. This thing they are asking you. This thing they are asking you. So, what you need to do, firstly, what is given to you, calculate the number of moles. Number of moles are already given for oxygen atom. Right, that is given to be 0.5 mole. Now, use the stoichiometry for HNO3. What stoichiometry you have? You know that in 1 mole, right, in 1 mole, compare this, in 1 mole of HNO3, you have 3 atoms of oxygen, 3 atoms of oxygen. That means, or not 3 atoms, you can say 3 moles of oxygen because mole are with mole only. So if you are talking about one molecule, you can even write this one more thing here, that one molecule of HNO3 has 3 atoms of oxygen, then you can say that one molecule, if I multiply both the things by Avogadro's number, I will get 1 mole of HNO3 will have 3 mole of oxygen. It will have 3 mole of oxygen. 1 mole of HNO3 will have 3 mole of oxygen, isn't it? Now, can you say one more thing here? Now, if you have 3 mole of oxygen, I know I have 0.5 mole. So, can I say 3 mole of oxygen? 3 mole of oxygen. I'll just reverse to this thing. Oxygen has 1 mole of HNO3. Now, if 3 mole of oxygen has 1, I'm just applying unitary method. That means 1 mole of oxygen atom will have 1/3 mole of HNO3, right? From here, 0.5 mole of oxygen atom will have 0.5 divided by 3 mole of HNO3, right? This is what I was talking about, unitary method. This is a unitary method that you need to apply, right? Whatever they are asking you, right, in front of that, you just need to apply the unitary method. Now you know that these many moles of HNO3 you have. Now they are asking you moles only, so simply you can say number of moles of HNO3 is equals to 0.5. 0.5 is what? 0.5 is 1/2, so it is 1/6, right? It is 1/6 mole of 1/6. These are the moles of HNO3. Now from here, if they ask you calculate the mass of HNO3, you can easily calculate that by molar mass of HNO3 multiplied by 1/6, right? If they ask you volume of HNO3, you can say that volume of HNO3 will be equals to 22.4, that is a molar volume, multiplied by 1/6. It will be in liters. If they ask you the molecules, that means the particles, we know that HNO3 is a molecule, so particles will become molecule. Particles will be equals to Avogadro's number multiplied by 1/6, right? Understood? So anything they can give you, anything you can calculate out of it, right? That is the use of mole concept, right? That is the use of mole concept. Whatever they are giving you, they are asking you volume, mass or particle, you can easily calculate this with the help of number of moles and the unitary method. Is this thing clear to everybody or not? Is this thing clear to everybody or not? Is this thing clear to everybody or not? Yes, guys, is this thing clear to everybody? Now, I think mole concept done. Now, after this, let us apply. Yes. Now, let us see some more things here, right? Okay. Yes, let us see some more things here. I think that is, do you want me to do one more question on this, or are you clear on this thing? So this is the concept, right? This is the concept that will be applied. This is the concept as I have told you. Same thing you are going to do. Same thing you are going to do everywhere, whatever they ask you, right? Okay, yes. Now, okay, let's do one more question. Okay, let's do one more question. This question we can do. Okay, this question we can do. So let's do this question. If you have M2SO4, I don't know what is this M, that you need to calculate. The weight percentage, okay, let us talk about firstly percentage, then we will solve this question, okay? Then we will solve this question. Firstly, let us see the weight percentage. After that, weight percentage we will see after stoichiometry only. So we'll do this question, wait for some time, right? Now, what is ideal gas equation? What is ideal gas equation? Ideal gas equation. Anybody in the chat box, what is ideal gas equation? Anybody in the chat box, what is ideal gas equation? Ideal gas equation is equals to PV is equals to nRT, right? What is this N? What is this N? N is the number of moles. So can I say this is PV, right? PV. Can I also write it as number of moles is equals to weight by molar mass? This is RT, right? So if I take it here, this will be P, this is molar mass, this is volume, this is, sorry, not volume, this is weight, and this is V, this is RT. W is the weight, capital M is the molar mass, and P is the pressure, T is the temperature, R is the gas constant. So P into M is equals to, what is weight by volume? Density is equals to mass by volume. We know that density is equals to mass by volume. So this is a very, very important formula that is usually ignored by the students. They usually ignore this. Then they say, ma'am, paper was very tough, right? So PM is equals to DRT. PM is equals to, you can say, PM is equals to Diksha Ma'am, right? Diksha teacher. Diksha teacher. PM is Diksha teacher. Okay, your PM is now Diksha teacher. Just kidding, guys. So PM is equals to DRT, right? Now, this becomes a very, very important formula, right? This becomes a very important formula. This is also a very important formula, right? So, can you tell me what is this R? Everybody, what is this R? Everybody in the chat box, what is this R? R is basically universal gas constant. R is basically universal gas constant, right? That is equals to 8.314, right? That is joule per mole per Kelvin, right? Joule per mole per Kelvin, or it is also like equal to like approximately we can take the value as 25/3, like to ease the numericals here. This is joule per mole per Kelvin. Like now, if you say this in calorie per mole per Kelvin, that will be 2 calorie per mole per Kelvin. Per mole per Kelvin. If you want to see this in liter atmospheric, that will be 0.0821, or it is approximately 1/12, right? 1/12, 1/12, not 7/12. Oye hoye. 1/12 per mole. This is liter atmospheric per mole per Kelvin, right? Okay, so these are the three values that we will use, right? These are the three values for, based on like your chapter to chapter, it will vary which value you will use, right? That is why this lecture is very, very important, because I am not going to tell you these things again and again and again and again, right? I am telling you these things now, but I will not repeat this, right? I will definitely repeat, but not in this much detail. Right? Okay, I'll just tell you that here you are using this value, here you are using this value. In this chapter, you will use this value, and in these kind of questions, you will use this value. This we will do throughout physical chemistry. Right? Okay? Yes? Yes, everyone? Yes, everyone? Yes, everyone? Now, we were at this question that was PM is equals to DRT. Right? So, can I say D will become equals to PM by RT? Very, very important. Now, if your density increases, pressure will increase, but temperature will decrease. So, basically, we can say that density is directly proportional to pressure, inversely proportional to temperature, right? Okay, inversely proportional to temperature, right? Okay, this is your density, right? Now, if we are talking about density, then let's also talk about vapor density. Then let's also talk about what is vapor density. Because a relation is very important with molecular formula or with molecular mass. What is the relation of this vapor density, right? Okay. Now, here you have vapor density. Vapor density is equals to molecular mass of that gas divided by molecular mass of H2, right? What is the molecular mass of H2? That is 2, and this is the molecular mass of that gas, and this is your vapor density of that gas. So that's why we say that molecular mass of gas is equals to 2 into vapor density. 2 into vapor density. So sometimes in the question, right, where they are supposed to give you molecular mass, they will not give you the molecular mass, rather they will directly give you the vapor density. And then you will think that, ma'am, molecular mass was not given to us, right? They have not mentioned anything about molecular mass, but because they have given you vapor density, that means just multiply this by 2 and you will get your molecular mass. Okay? Okay, guys? Yes? Yes, everybody? Yes, everybody? Now, let us see the laws of combination, laws of chemical combination. Right? Let us see the laws of chemical combination. Very rarely they ask question based on this, but you never know. Right? Because from last 3-4 years, so they are not asking anything from these chemical combination. But see, you never know about their mood. Suddenly they will ask in NEET 2025, you will be like, ma'am, this was not in previous year question of last 5 years, ma'am, what to do? Right? So we are not supposed to skip anything, right? That is why there is this NEET Express for you, so that you don't skip any. Ma'am, it will take so much time, ma'am, I will just skip this. No, why you want to skip things? Right? I am here to teach you in a very fast manner, not in a exactly very fast manner, but yes, why I am writing everything here? See, that is not possible 1 month before. Right? 1 month before, I'll only like focus on practice and give you this formulas. Right? Right now is the time where you can clear your concepts in a very short time. Right? Right now we still have time for that. Right? That is why this thing is for you. Right? Okay? Yes, everybody? Now, we have laws of chemical combination. So basically it is governed by 5 basic laws. First law is law of conservation of mass. Now this means that the mass of reactant in overall reaction is equals to mass of products. Your mass of reactants in overall reaction is going to be equal to mass of the products. Yes, you can also say concentration, mass of reactants, mass of product, that is going to be remain the same. After the reaction, you will not get suddenly out of that, right? Now, mass of reactant is equals to mass of products. From this, we can say that why we balance, application of this law is we balance the equations. Do you know why we balance the equation? To balance the atoms, because we want that number of atoms on reactant side, that should be equals to number of atoms of that same element, right? Number of atoms on product side, right? That you need to know, that number of atoms on reactant side should be equals to number of reactants on the product side, right? Okay, that is why law of conservation of mass is used. Second law is law of definite proportion. What do you mean by this law? Law of definite proportion. Law of definite or constant proportion. What do you mean by this law? That whatever compound you are taking from any source, let's say any source you have, right? You are taking water from maybe some pond, maybe from from your home only, maybe from Canada, America, Africa, anywhere you take water, water is going to stay H2 only. It's not like water of India is H2O, but ma'am, water of America is ma'am H3O. Ma'am, water of Europe is ma'am H2O2. No, that is going to remain the same only. So that means the number of atoms are going to be same in the same definite constant proportion. Always in water you will have same number of atoms of hydrogen and oxygen. Always 2 hydrogen, always 1 oxygen. Right? Okay, that is how we study chemistry, right? So that was the second law. Third law is law of multiple proportion. Law of multiple proportion. Anybody in the chat box? Law of multiple proportion. This means that law of multiple proportion simply means that if you have H2O, then it is existing in a whole number ratio. You can't have this kind of thing, H2.5, O1.5. Have you ever seen these kind of compounds? No, right? So these kind of compounds will not exist, right? Always the ratio of the atoms is going to be a simple whole number ratio, right? The ratio of the guys, stop chatting with each other. What you guys are talking with each other? Huh? Focus on what I am teaching you rather than talking to each other about this and that stuff. This is not chit chat stuff, right? Okay. Now, ratio of atoms is in simple whole number ratio. Simple whole number ratio. Right? That is going to be in simple whole number ratio. Now, there is one more concept that they tell about multiple. This was a simple definition. Now, I'm telling you a complex definition. Right? The complex definition says that you have a compound that is existing as 2 compounds. You have 2 atoms that can exist as 2 compounds. Let us take about one more easy example. For example, carbon dioxide and carbon monoxide. You have carbon monoxide and carbon dioxide. Both are from the same elements. You are having 2 compounds here. Now, the complex definition says that if you fix any of it, I am fixing the mass of carbon. If you fix the mass of one element, then the ratio of this oxygen to this O2, this means 16 to 32, that is going to be a simple whole number ratio. That is going to be a simple whole number ratio. This is the complex definition, simple whole number ratio. Okay, that is going to be a simple whole number ratio. Okay, yes. Oof. Guys, what's your problem, yeah? How many students are here to study? Chit-chatting with each other. Hi, how are you? I am fine, thank you. Huh? Let's talk about this and that. What are your aim in life? What's your aim in life? To get a girlfriend? That's your aim in life. Or to get a seat? You can only focus on one thing here. Either you can get a girlfriend or you can get a seat in medical college. Girlfriend will not give you anything, right? That is going to break your heart after maybe 1 or 2 years, right? Then you will be like crying like somewhere, right? But now, if you have the seat, it will stay with you. It is going to give you money. It is going to give you respect, right? So stop chit-chatting with each other. Okay, you are not doing anything wrong with me. I am so okay, I am so fine, I am so teaching only. Those students who want to study, they are studying, right? But what you are doing, wrong to yourself, wrong to your parents, right? 5 months, yeah, just 5 months left for your NEET exam, right? It's almost 8:30 and I'm standing here in front of you. I'm teaching you one shot, some basic concepts of chemistry, everything in a very crisp manner I'm teaching you so that you can revise everything in a good manner. But still, if you're not able to do that, then bad on yourself, right? Okay, so this is your simple whole number ratio. Okay, what is the 4th law? 4th law is Gay-Lussac's law. Gay-Lussac's law, right? Gay-Lussac's law, right? Now, What about this law? Gay-Lussac's law. Now, what does it tell about your, for example, I am just telling you in a very simple way, you have x of x2, y of y2, and it is making a equation of xy, maybe some x into maybe some z xy. Let us say it is making xy here, right? You are having xy here, that is maybe x into y, or any stoichiometry, new stoichiometry that I am saying as z. Okay, that is a new stoichiometry, right? Now, what we want to say that the ratio of this x and y is always going to be in simple whole number ratio. Simple whole number ratio, right? The ratio is always going to be a simple whole number ratio. Like here, x and y can be 1:1, 1:2, 3:4, 8:2, anything it can be. It should be a simple whole number ratio, right? Okay, that is what Gay-Lussac's law tells us. Then you have reciprocal law. Reciprocal law. Reciprocal law. Now, reciprocal law is not written in your syllabus. It is not there in your syllabus. But still, I'll teach you what exactly is because you never know. With NEET, you never know what they will ask you in the exam. They'll say law of chemical combination is there, and reciprocal law is not there in your NCERT, but you have law of chemical combination, so they can ask you that, right? So basically, what is this reciprocal law? So I'll give you a very simple example of this. For example, you have two compounds, right? Let's say you have SO2 and you have CO2. These are the two compounds that you have, right? So I'll write it as CO2 and SO2, right? Which have one same element. That element is oxygen. That element is oxygen, right? They are saying that apart from that same element, fixing that same element, fixing the mass of that same element, it is also 32, here also it is 32. If the other element makes the try to make the new compound, that is CS2. This is the new compound. Now this ratio of this carbon and sulfur is going to be a simple whole number ratio. That means you can tell me this thing here, that here it is what? It is carbon is 12 and this is 32 into 2, that is 64. Right? So we know that this is a simple whole number ratio, right? That is a simple whole number ratio. You can see that 2, 6 and this is 3, 2, that becomes 3 and this is 1, 6. 3:60, right? So now this is your simple whole number ratio, right? This is your simple whole number ratio. Why I am giving you examples? Because if I don't give you examples, you will get confused. The statement is like this. Two compounds with the same element, two different elements with one same element, they form a compound. They form two different compounds. And when these two elements together form one compound, then the ratio will be a simple whole number ratio. Right? Okay? Understood this thing? Yes, everybody? Right? Okay? Ma'am, 1 can be said as 2:1. No. 1 into 1.5. 1.5 is what? 1.5 is in fraction. What is the number? What is the number of 1.5? It is 3/2. Is it? I think so. Yes, 3/2. So it is 3/2. It is 1. So it will be 2:3. Okay. So eventually you will get a fraction, whole number ratio only. Right? Okay. Eventually after solving you will get a whole number ratio. Right? Okay. Now next is these are your laws, and now last law, very simple law, that is Avogadro's law. Avogadro's law, very, very simple. Avogadro's law. Now, with Avogadro's law, remember one thing. They are saying if you have same number of, same volume, same amount or volume, same amount or volume, you can say equal volume or equal amount of two gases, you have the same volume, then will have same number of molecules. If the volume is same, you have two different gases, but the volume is same, then the molecule will also be same number of molecules and same number of moles, right? And same number of moles. Let's say I have H2 in a beaker and you have Cl2 in a beaker, right? I know the size of Cl2 molecule is bigger as compared to H2, but if you have the same volume here, right? Now Avogadro told that the same volume, for example, this is also X and this is also X. Here the number of molecule is N, then here also the number of molecule will be N only. For example, here the volume is X and here the volume is 2X. And here the number of particles or molecule is N, then here the number of molecules or particles will be 2N. Okay, so that is going to be in ratio to each other, right? Okay, everybody understood? Very simple law. If you have same amount of volume or amount, right? Amount is same, volume is same, two different gases, then number of molecules and number of moles is going to be same only. See, if you talk about number of molecule, number of moles, same only, na? So just multiply molecule with Avogadro's number, you will get mole only. This is nothing but mole only, right? So that was your Avogadro's law, right? That was Avogadro's law. Okay, guys? Okay, everybody? Is that clear? Is that clear? Is that clear, guys? Is that clear? Is that clear? Now, let us see. Do you want to study stoichiometry or empirical formula? Let us see what you want to study first. What you want to study? I want to know that. Right? I'll teach that thing only. Stoichiometry or empirical formula first. Let us see what you find interesting. Stoichiometry or empirical formula. Let us see that. Which one is your favorite? Mine is empirical formula. That is very simple. Right? What's yours? Stoichiometry or empirical formula? Yes, ma'am. Yes, ma'am. Yes, ma'am. Stoichiometry, empirical formula. Empirical formula. Stoichiometry, empirical formula, stoichiometry. Okay. 1, 2, 3. Let us see what is like in majority what you guys are saying. Let us see in majority what I want to see that spam in the chat box, what you guys are saying, right? Stoichiometry, chemical kinetics, wah, shabash. Stoichiometry, okay. So stoichiometry you want to study. So let us study stoichiometry. Spelling to even I don't know mine is correct or not, right? But our question should be correct. That I can guarantee. Now, if you talk about the stoichiometry, that is actually related to mole concept. So, yes. So now firstly, let us see what do you mean by stoichiometry. I'll take up some question here. So stoichiometry simply means that, for example, I have SO2, I have this reaction. I'm going to take up one reaction here. Reaction is SO2 plus O2 give rise to SO3, right? This is the question. Now, law of conservation of mass. Firstly, balance this question, right? Balance this reaction. This is the balanced equation. We know that here 2 sulfur, 6 oxygen, 2 to 4, 6 oxygen, 6 oxygen atoms, right? Now, stoichiometry means that in simple language, it means that here if I say I have 2 mole, if I say I have 2 mole, it is 1 mole and here it is 2 mole, here it is 2 mole. These are the standard things from the reactions, very, very important thing I am going to teach now, right? Now, if I say 2 here, it can also be taken as 2 molecule. 2 molecule, here you have 1 molecule, here you have 2 molecule, right? Here you have 2 molecule. In mole concept, you had 4 things: number of moles, mass, you had particles, atoms or molecules, that means you had volume, right? So particles, so we have seen. If we want to see the particles, we want to see the volume. Let's say we want to see the mass. So this will be 2 into, this will be the, not the mass, because given mass will be that much, right? Okay, let us see the volume here. So volume will be 2 into 22.4. This is going to be 22.4 and this is going to be 2 into 22.4, right? So that is the thing. Okay, yes everybody, yes everybody, right? Mass also, if we want to see mass of SO2, this is mass, molar mass, right? This is 2 into molar mass of SO3. Right? This is basically stoichiometry. That from the questions, right? See, understanding stoichiometry is one thing. Applying stoichiometry is another thing. That is the tough part, right? So firstly, to apply the stoichiometry, you need to understand what exactly do you mean by stoichiometry coefficient. So these are the stoichiometry coefficients, right? Here we can write 1, right? So now it will tell us that we can write it in the form of, from this reaction, I can say 4 things here. That 2 moles of SO2 reacts with 1 mole of O2 to give 2 mole of SO3, right? In the form of molecules also we can say, in the form of volume also we can say. Mass is not usually used, right? Okay, so now we will see the application here, right? We will see the application here. Let us see the application. For application, I have one question for you, so that from, see, these questions, these concepts can only be understood with the help of some questions, right? Otherwise, though, it's all easy. You will see, ma'am, okay, this is stoichiometry, next question, next topic, right? So you need to understand this with the help of questions. I'm going to give you one question here, right? Okay, so let us see one question here. That is, you have CH4 plus you have 2O2 give rise to CO2 plus H2. So that is your question here. Now you need to tell me one thing, that this is your full-fledged question, right? So now you need to tell me that what exactly they are asking you and what they are giving you, right? So there are 2 things. One thing will be asked, one thing will be given to you. Let's take any, like I'll tell you one by one. For example, 10 gram is given to me. 10 gram is given to me. Here they are asking me the, let's say the volume. Let's say the volume. Here they are asking me, let's say the mass. Here, let's say they are asking me the particles, right? The molecules. So in this one question only, I'll like tell you everything what we can answer from this one equation, and just this one hint. Only one hint is given to me. And in stoichiometry questions, you will always be given with the reaction, right? So now this reaction is given to you and they have given you just one hint. And they can ask you anything here. They can ask you volume, they can ask you mass, they can ask you even the mass of this thing, the particles of this thing, the volume of this one, the mass of the particles of this one, the mass of this one, the volume of this one. So you can calculate anything from here. But how? So firstly, do you want to see the full-fledged answer of this, or you want to directly jump to the trick? See, firstly, I'll give you what is the full-fledged answer here, right? So how you need to calculate. Let us focus on one thing. Let us focus on only one thing, that calculate the mass of oxygen. This is the question, that calculate the mass of oxygen that they are asking you, right? Calculate the mass of oxygen that they are asking you, right? So for that, what we will do? First is I need to erase this thing, right? Then I need to write it down here. This is CH4, 2O2 give rise to combustion reaction. This is CO2 plus H2O, right? Now firstly, same thing that I told you in mole concept, same thing will be applied here. This is given, and this is asked, and this is asked. Those who will not be able to, don't wait for the trick, ma'am, I will not do the full-fledged answer, I will only apply the trick. Trick you will only be able to understand if you do the like complete answer, detailed answer. Only then trick will be useful for you. Otherwise, trick is also, you can do mistakes in the trick as well, right? Now, here given is this, asked is this. I told you one thing, that what you need to do whenever you have this kind of situation. Firstly, calculate the moles of what is given to you, right? So given to me is CH4. So I will calculate the moles here. I will calculate the moles. The moles is 10 gram. The moles will be calculated as given mass by molar mass. Molar mass is what? Molar mass is 12 plus 4, that is 16, right? So this is 16. That will be your number of moles, right? So it becomes 5 and this is 8. So 5 by 8 moles. So these are your number of moles, right? These are your number of moles, right? Okay. So I want to make it easy because we want to make the calculations easy, right? So let's take this as maybe take this as 32, right? Okay, let's take this as 32 so that the calculations can be easy for us. So it will be given mass by molar mass. Molar mass is 16, right? So it will be 2 moles, right? It will be 2 moles. Just to make the calculations easy, because we need to deep dive into the concept, not the calculations, right? So number of moles of CH4 will be 2 moles, right? Simple. Now I told you that given thing, firstly, for the given thing, calculate the number of moles. After that, apply the stoichiometry. Now you need to apply the stoichiometry of what is asked to you. See, 1 mole of CH4 is reacting with 2 mole of, because what we are focusing on oxygen, right? So let's focus on 1 mole of CH4 reacts with 2 mole of O2, right? We have, that means 2 mole of CH4 will react with 4 mole of O2, 4 moles of O2, right? That means number of moles of O2 we have, that is 4 moles, right? Same thing I am applying. From the given, you calculate the number of moles what is given to you, then unitary method apply, then you will get the number of moles of O2. Now they are asking you, for example, they are asking you the mass, right? Let's see, they are asking you what they were asking here. They were asking the volume, no? So volume will be number of moles of O2 equals to given volume. I don't know what is given volume, but molar volume I know, that is 22.4. So given volume will be equals to number of moles, that is 4 into 22.4 liters. That is going to be the answer. Okay, that is going to be the answer. So this is how in detail you can calculate for anything. Now I have compared this with oxygen. You can compare this with carbon dioxide. 1 mole of CH4 will give us 1 mole of CO2. So number of moles of CO2 will become, 2 only. Number of moles of H2O will become 2 only. Number of moles of O2 is 4, right? Okay. From there you can calculate anything, right? You can calculate the mass, volume, particles, anything is given to you. And here also they could have given you the volume also. You can calculate the number of moles. From there you can proceed. Now tell me guys, is this thing clear to everybody or not? Now I am going to give you one trick here, right? Now we have one trick, right? We have one very simple trick for this one, right? Okay. Chalo. Now the trick is, this is CH4 plus this is 2O2, this is CO2 plus this is H2O. Here let us see, this is 10 grams is given to you. So the trick is crisscross, right? Cross multiplication you are going to do, right? A very, very famous trick it is, right? Very, very famous trick, right? So now you can use the crisscross method here. That means, what do you mean by crisscross method? So what they are asking you, for example, they are asking you the volume of O2, right? Just write down volume of O2, right? Firstly, you need to tell me what is given to you here, right? Crisscross means here if the volume, if they are asking you the volume, see, very important thing here. If they are asking you the volume here, you need to write the volume only here. Volume will be 2 into 22.4. That is going to be the volume. The volume will be 2 because 2 moles you have. So 2 into 22.4, right? Molar volume you will write, right? Here, what is a molar mass? Here you will write the standard, and here what is given, and here what is given to you. This is the trick I am telling you, right? What is given, what is asked. Now, what is the molar mass here? That is 16 grams. Now, what you need to do the crisscross. Volume of O2 is equals to, just what you do, this will be, here this will be multiplied, right? These two things will be multiplied with each other. These two things will be multiplied with each other. Volume of O2 will become, this is given, multiply by, wait a minute, this volume, this will be multiplied by 16, and here these two things will be multiplied, 10 into 2 into 22.4, and this will become, V of O2 will become 10 into 2 into 22.4 divided by 16, right? Okay. Then what you will get, wait a minute, 8, this is 5, this is 4, 5 by 4 into 22.4. Wait a minute. Wait, that's why I was thinking that why I'm getting the wrong answer. Wait a minute. This is your, I have taken 32 grams here, no? So this will be, multiply these two things, V of O2 multiplied by 16, multiply these two things, 32 into 2 into 22.4, right? So volume of O2 will become 32 into 2 into 22.4 divided by 16. It will become 4 into 22.4, right? Okay. So in just like in seconds you got the answer, right? Okay. In seconds you got the answer. What I did, I wrote down the, basically what I wrote down, what is asked to me, I wrote down everything here. Here volume was asked to me, so I wrote down the molar volume, like in standard situation, it will be 2 into 22.4. And here the volume, what I am thinking should be V2, that is volume of this oxygen that I want to calculate. Here it is given to be 32, but the molar mass is 16, right? So just crisscross. V into this and this into this, just equate them and you will get what is required. Okay. Now, if you want to see, if you want to calculate not the volume here, if you want to see and calculate the mass, right? Here what we were thinking, to calculate the mass. Okay. Now here they are asking you the mass here. So I am taking the mass of CO2 as m of CO2. What is the molar mass of CO2? That is 44 grams, right? Okay, 12 plus 32, right? That is 44, right? Now, again, I will use a crisscross method only. Again, I will use the crisscross method. What is this method? This will be multiplied by this, mass of CO2 multiplied by 16 equals to 32 multiplied by 44. 32 multiplied by 44. Here mass of CO2 will turn out to be 32 into 44 divided by 16. Now this is 16 into 2, right? That is 88 gram of CO2, right? Okay. So that is your second answer, right? Okay. Direct answer, right? Okay. Directly you can see this. Directly you can even answer this thing here. Right? Now, will you be able to answer me the particles of H2O? The particles of H2O. Now, you need to answer me the particles of H2O. Anybody in the chat box? The particles of H2O you need to answer me. Right? Forget about these two things. Now, answer me the particles of H2O. Right? Here you need to see the particles of H2. Particles means H2 is a molecule. So it means molecule they are asking you. Molecule they are asking you. Right? Okay. Okay guys. Okay guys. Here you have how many molecules? One molecule. If I say this is one molecule, this is two molecule, this is one molecule, this is one molecule. That is the use of stoichiometry, right? So it is one molecule is given to me here. In the standard state, we have one molecule. Crisscross it. So this will be number of molecules. This you can write it as, this you can write it as, this you can write it as N of H2, right? Not N, this is, should be capital N of H2, that is number of particles or molecules, right? You just need to cross multiply this. N of H2O multiplied by 16, this multiplied by this one, this multiplied by this one. This will be 32 into 1. So that is number of particles of H2O, that is 32 by 16 into 1. That is going to be 2 molecules of H2O, right? Okay, if you talk about the molecules, right? Okay, wait a minute. Oops, the equation is not balanced. Yeah, the equation is not balanced. The equation is not balanced. Here it should be 2, here also it should be 2, here also it should be 2, here also it should be 2, right? I think now the equation is balanced. 1 carbon, hydrogen is 4, oxygen is 2, 4, oxygen is 4. Yes, now it is balanced. The answer will change here, right? The answer will change here. Here then you will have 2 molecules, right? Okay, here you will have 2 molecules, right? So here it will be 2 molecules. Here you can write 2 molecules, right? So here again apply that thing here, again apply that same thing here. So crisscross, number of particles of H2O multiplied by 16 equals to 32 into 2, right? Number of particles to H2O will be 32 by 16 into 2, that is 4, right? That is 4 molecules of water in this equation, right? Okay, everybody in the chat box, is this thing clear to everybody? Now will you find stoichiometry tough or easy? Now stoichiometry is tough or easy? Easy, right? It's a task of 2 seconds, is it? Now it's a task of 2 seconds, right? Okay, same way we are going to do limiting reagent, trick based limiting reagent, simple way, right? Simple direct way of calculating limiting reagent, right? Now I want everyone to have green hearts in the chat box, right? For your Diksha Ma'am, green hearts in the chat box for your Diksha Ma'am if you are finding stoichiometry easy now, right? Okay, easy when I am here. Yes, I am here to make things easy only for you, right? Okay, so now just crisscross. Yeah, you just need to crisscross these things, just crisscross. This is multiplied by this, this is multiplied by this. What is tough in that? This is multiplied by this, this is multiplied by this. Everywhere we are doing the same thing. I know this method can be tough for so many of you, but I would advise you guys also to know, at least you should know this method. That's why I told you in detail also what should you do and what is the trick. The reason was because this method is applied, like for example, they have asked you a question not from stoichiometry, but for example, from simple like mole concept, they have asked you the question. Same concept is applied. Okay, understood? Now, next is Nandu is saying, ma'am, not able. Now, Nandu, tell me, how should I tell you how to crisscross? Crisscross is like this. This is multiplied by this. This is multiplied by this. This is your crisscross. Okay. Cross multiplication you need to do, yeah, simply. Okay. Now, next is limiting reagent. It is also a form of stoichiometry only, right? A part of stoichiometry questions, right? Limiting reagent. Limiting reagent means the one which is in deficiency. That means the one is the one reactant which is less in quantity, right? So for example, you have A plus B, right? These are the two reactants, right? For example, this one is 25 grams. Here standardly you require 50 gram of this one. This is standard. This is standard. That if you want this reaction to happen, then you require 50 gram of A and you require 25 gram of B. This is the standard thing that you should have. But in reality, you had 25 gram of this, but then you had maybe 40 gram of this, right? Okay, you had 25 gram of this and 40 gram of this. That means we now know that here it is in limited quantity. We required 50 gram, but now we only have 40 gram. Now, what will happen? Instead of 50 gram, only 40 gram will react, right? That means you can say 50 gram will react with 25 gram. But as you have only 40 grams, so it will react with, you can say 1 gram react with 25 by 50 and 40 gram will react with 25 by 50 multiplied by 40, right? So, 40 gram will react with, this is 1 by 2 and this is 20, right? This will react with 20 gram. So, what you will see that in that reaction, if you have 40 gram, out of this, only 20 gram will react, will be consumed. That means 25 minus 25 gram is in excess, right? Why I am telling you this with the help of some example? Because with example, right, this will be easy for you to understand, right? So now, again explaining, limiting reagent means one of the reactant is less, right? So now, standardly, like I am saying, like standardly, if I am saying that you have 25 gram of this one, then 50 gram of this is required, that I have given you standard, right? Now, in the lab, you ask the lab attendant that, please give me, do you need break? Do you need break? I think just 3-4 topics are left, right? Purity, yield, purity percentage. Then you are left with concentration terms. So if you still need break, then tell me, but I think that will break our flow, right? Because most of the things so we have done only. Like our chapter is almost like we are ending that chapter, like maybe in next half an hour, right? Okay. Now, see, in the lab, you ask the lab attendant that 40 gram, you ask them 50 gram of AI require and 25 gram of BI require. They are saying that, oh ma'am, we don't have 50 gram of A, we have only 40 gram. Then you will say, oh my God, then what will happen? Now they have given you 40 gram of this and 25 gram of B. Now you need to see which is a limiting reagent, which is in excess. Definitely this is limiting, so what we require, we don't have that much, right? So now here exact amount is given to us. That is why this A will become the limiting reagent. We know that this is from Unitary and this is exact detailed that I am telling you, but I'll give you the trick in the next step, right? So we know that 50 gram reacts with 25. That means 1 gram will react with 25 by 50. That means 40 gram will react with 20 gram. That means in the lab, that A will react with how much of B? 20 gram of B. That means 5 gram will be unreacted, right? This will be unreacted and this will only react. That is why B is the excess reactant. This is the limiting reagent. Okay, that is the excess reagent. This is the limiting reagent. Understood this concept of limiting reagent and excess reagent, right? Now, ma'am, what is the trick to solve these kind of questions? Okay, so you can just write down the trick here with the help of equation or reaction only. I will tell you that what is exactly the trick, right? So let us see Haber's process only. Let's take Haber's process. Yes. Now, for example, it is given to be N2 plus H2 give rise to NH3. Firstly, everywhere, whether you are applying mole concept, stoichiometry, limiting reagent, anything you are doing, always firstly balance that equation. That is the first step that you require, right? So if you balance this equation, it will become 2 and this will become 3. This is the balanced equation, right? This is the balanced equation. Now, stoichiometry will be applied here. But I'll give you the trick, simple direct trick for this one. See, remember GS. What is GS? What is GS? Gopika ma'am and Shreyas sir, right? Gopika ma'am and Shreyas sir. Or you can say general science. It totally depends how you remember this, right? GS, right? Okay. So now, this GS means that you need to firstly see what is given in the question, right? For example, in the question they are saying that you have 2 mole of, in the question for example they are saying that you have 2 mole of N2, right? In the question for example they are saying that okay, 10 mole, let us take 20, right? 20 mole of this and 20 mole of this is given to you, right? There firstly the simple question can be asked based on limiting reagent. So directly how you will calculate, a simple trick on that. This is 20, this is 20, that is given in the question. In the question they will give you that 20 mole of this I have used, 30 mole of this I have used, this they will give you in the question, right? Now, what is there in the stoichiometry? What is there in the stoichiometry? Stoichiometry, students, that means stoichiometry is with the help of reaction. It is 1 mole and it is 3 mole. I told you, remember GS. GS means G by S. That means given by stoichiometry. This is the trick, okay? 20 by 1, this is 20 by 3. Now tell me which is the lower value. Which is the lower value here? Which is the lower value? Lower value is this one. So the lower value will be your limiting reagent. Lower value will be your limiting reagent. That is going to be your lower value. Understood? That is going to be your lower value. That is your limiting reagent. Right? Okay. And definitely the other reagent is going to be the excess reagent. That is higher in value. That is your excess reagent. That is going to be your excess reagent. Okay guys? Okay guys, is that clear? Is that clear? So I want to see some question based on this. Let me see. Let me see. Let me see if I can find out some question based on this. Okay. So the question is from your N-Avasthi only you have this question, right? It says that consider the reaction. The reaction is given to be 4A plus B plus 3C give rise to P plus 2Q. P plus 2Q. This is the question that is given to you. Starting with 6 mole of A. Now this is given in the question, okay? I am not writing the full statement. I am just giving you, orally telling you that equation, right? 2 questions we will do for limiting reagent, okay? So they are saying that starting with 6 mole of A, they have given you. 2 mole of B they have given you, right? And they are saying 4 mole of C. 4 mole of C. Number of moles of Q after the reaction will be Q they are asking you after the reaction. Okay? Okay? 2 they are asking you after the reaction. Right? Okay? Now, simply what we need to do, this is question from N-Avasthi and N-Avasthi has very good questions, right? Okay? Now, this is G by S. Now tell me stoichiometry is 4 then 1 then 3, right? Now G by S is going to be 6 by 4, 2 by 1, 4 by 3. That means this is 3 by 2, 2 and 4 by 3. Now See 2 here 2, this is going to be 1, then 0, 2, 5, 1.5, right? This is 2, and what is 4 by 3? 313, 3.0, 339, 1.3, right? Okay. So here tell me which is the lowest value. Which one has the lowest value? Which one has the lowest value? This one has the lowest value. Lowest value, that means this is going to be your limiting reagent. So can I say everything, the product is dependent on the limiting reagent, right? How the product is dependent on the limiting reagent? If you see this thing here, firstly I calculated how much amount of limiting reagent. This was my limiting reagent. This was not my limiting reagent, this was my limiting reagent. Based on the limiting reagent, I calculated how much amount of B was used. That means how much amount of excess reagent will be used was dependent on the limiting reagent. How much amount of product is formed is dependent on the limiting reagent only. So you can write one thing here. Product is dependent on limiting reagent. Product is totally dependent on the limiting reagent. It is dependent that how much amount you are using, right? Okay. So now that means if I say 1.3, this is not how it is dependent, but it is dependent on C. So C is the limiting reagent, right? Now what we need to do, just copy paste this thing. Now you will apply unitary method here, right? With C, what you will apply here, see simply what you will apply here. There are also tricks for the next page, but I will not tell you that. Reason is you will get confused. Don't do so many tricks that you remember, that you forget about all the tricks, right? You are like cramming so many tricks, you are not able to, you're not able to recall that many tricks. So why to do that, right? Here the trick is important, but otherwise, so you can apply unitary method simply, right? So there are two things that you need to compare it with, right? So one is your C and what they are asking you is Q. So these are the two things that you need to focus on. Erase the other things. Just erase other things, right? Erase other things. Now, in the stoichiometry, it is given to be 2. So what you need to calculate? You need to calculate Q, right? So we will say 2 moles of Q, it reacts with 3 moles of C. That means 1 mole of Q, wait a minute, opposite we should write, no? 3 mole of, because Q we want to calculate, 3 moles of C reacts with 2 moles of, gives 2 moles of Q. When you have 3 moles of C, you will get 2 moles of Q. That means, can I say that if you have 1 mole of C, it will give you 2 by 3 mole of Q. Now, we know that in the limiting reagent, we have 4 moles. 4 moles of limiting reagent. Always it is dependent on the limiting reagent. So, say 4 mole of C will have how many moles of Q? 2 by 3 multiplied by 4 mole of Q. That means 8 by 3 mole of Q is your answer. Right? 8 by 3 mole of Q is your answer. Okay, guys? Okay, everybody? Is that clear to everybody here? Is this thing clear to everybody here? Do you want to have one more question based on this? Do you need one more question, right, based on this? See, 56 gram of N2, they are saying 56. Now here, they have not directly given you the moles. Reacts with, here you can apply, here first you will apply stoichiometry, mole concept and limiting reagent, right? So reacts with 179.2 liter, 1 liter H2 gas at 1 atmospheric. At 1 atmospheric means what is the molar volume? Everybody in the chat box, if they have given 1 atmospheric and 2 273 Kelvin. What is going to be the molar volume here? Everybody in the chat box. To form NH3. Now they are saying, what is the mass of NH3? What is the mass of NH3? Right? This they are asking you. Right? Okay. Firstly, write down. We know that this is Haber's process. This is 2H2. No. N2 plus H2. Right? That is 3. This is going to be 2NH3. Right? That is going to be the thing. Now, what is given to you? Given to me is 56 gram. 56 gram. 56 gram. Here it is given to be 179.2 liter. This they are asking. So can I firstly calculate the number of moles here? Everything, mummy. Firstly, whenever there is some problem, you will call mummy. This happened, right? So this is your mummy. Mummy is moles. So firstly, you will call moles. So that is given mass by molar mass, that is 14. This is given volume by molar mass, that is 22.4. And this is your, this we don't know, right? This we don't know. So number of moles is going to be, students, everybody in the chat box, what is going to be the number of moles here? Everybody in the chat box, what is going to be the number of moles here? Everybody in the chat box, right? Everybody in the chat box, 179.2 divided by 22.4, yes. So this is 4 and this is, just calculate this will turn out to be 4 and this will be 8. Now, the stoichiometry is, now that was not given to you. First, you had to calculate the number of moles, right? Now, the stoichiometry is 1 and this is 3. So, what will be G by S? Everybody, what is G by S? G by S is 4 by 1 and this is 8 by 3. What is 8 by 3? This is 3, 3 to 6, right? Definitely this is less, no? So, this is 2.03, 2.6, no? So, it will be 2.6, right? It is 2.6 only. So, definitely it is smaller value. It is definitely the smaller value. So, can I say that this is my limiting reagent? This is my limiting reagent. So, here can I say H2 is limiting reagent? Firstly, so they can ask you which is limiting reagent. So, is this clear that how H2 is limiting reagent? We know that H2 is going to be the limiting reagent. From this, can I calculate NH3? Now, NH3 product formation is dependent on which thing? NH3 product formation is dependent on H2 or N2. It is dependent on H2 or N2. I want to see that in the chat box. Is it dependent on H2 or it is dependent on N2? Is it dependent on H2 or it is dependent on N2? Everybody, I'm waiting for your answers. I'm waiting for your answers. Very good. Here it was given to be 1. No, given to be, this was 4 and this was 8. This was 1 and this was 3. This was given and this was stoichiometry. Stoichiometry we don't need. Given we need. Now it is dependent on which thing? It is dependent on H2. So just ignore this thing here. Right? Just focus on this thing and this thing. Right? Now, here we know that here you have 3 moles to 2 moles. Right? So firstly calculate the number of moles of NH3. So we can say that 3 moles, we can say that 2 moles of, or you can say that 3 mole of H2 will give us 3 mole of H2. 3 mole of H2 will give us 3 mole will give us 2 mole of NH3. Unitary method. That means 1 mole of H2 will give you 2 by 3 mole of NH3. Right? That means, can you say that 8 moles, if I have 8 moles, that is in the question, 8 moles of H2 that I calculated here 8 moles. These are the moles of N2. These are the moles of H2. right? So here 8 moles of H2 will give us 2 by 3 into 8, that is 16 by 3 of NH3 is formed, right? Okay, these are the number of moles of NH3 is 16 by 3. Now, can I calculate if they ask you volume, if they ask you mass, if they ask you particles, can you calculate from number of moles? The use of mole concept, you can calculate anything from here, right? You can calculate anything from here, but they are asking me the mass. So I will calculate the mass, that is equals to mass of NH3 multiplied by number of moles multiplied by molar mass, right? Multiplied by molar mass of NH3. So what is the molar mass of NH3, guys? What is the molar mass? 14 plus 3, that is 17. So it will be 17. That is going to be your answer, right? That is going to be your answer. Right, everybody? That is going to be your answer. Is that clear? Is that clear to everybody here? Is that clear to everybody here? Right? Is that clear to everybody here? Is that clear? Oops, so sorry. 28 plus 3. So sorry, so sorry. Yes. No, why 28? Why 28? Now, why are you saying it's 56? Because 56 by 8 is 2. 8 by 3. N2 will be limiting reagent, ma'am. Wait a minute. How come N2 will be limiting reagent? Why N2 is limiting reagent? This is 56 by... Okay. Oops. I'm so sad now. Oops. Okay. So sorry, guys. One mistake I have done here. I'm so sorry about it. In a very speed up manner. This is a big blunder that I did. Right. Wait a minute. Yes, the limiting reagent will change here. Right. Okay, I'll tell you why. Reason is the mass is 28 because it is 2 molecules of nitrogen. 1 molecule has 14, 2 molecule has 28. Right, so 28 into 2 it is 56 by 28. It is 2. Right, so the number of moles of NH2, the number of moles of N2 is 2. So it will be stoichiometry is what? Stoichiometry is 1. So it is 2 by 1 and here it is 8 by 3, that turns out to be 2.6. So yes, this is your limiting reagent. Wait a minute. This is your limiting reagent. Who was the one who corrected me? Very good, Soumya. Very good, Soumya. Shabash. So everyone, firstly, to clapping for Soumya. Right? Yes, I did a very blunder here. Right? So here, this is your, my bad. I'm so sorry about it. Right? So this is limiting reagent. Right? 2 is the limiting reagent. Now, after 2, here we can write one more thing. What are the changes? Then N2 is the limiting reagent. N2 is the limiting reagent now. Now, everything will be dependent on N2, right? Now, everything is going to change, guys. So, here we will write, instead of H2, we will write N2 here. So, I'll just erase everything here, right? I'll just erase everything here and wait a minute. Oops, I'm not able to use this. Okay. Yes. Now, everything is dependent on N2, not H2, right? So, N2 is 8. So, now things will change as we can write here 1 mole of N2 will give us 2 mole of NH3, right? That means 8 mole of N2 will give you 2 by 8 of NH3. That means 1 by 4 of NH3. If you have 1 by 4 of NH3, that means the number of moles of NH3 is going to be 1 by 4, right? So, mass of NH3 is going to be 1 by 4 multiplied by molar mass of NH3, that is going to be 17 by 4. Right? Okay? Okay, everybody? Okay, this is 4. Once you do one blunder, then all the things are blunder happening. So it should be 2 by 4, right? That is 1 by 2 of NH3. Wait a minute, 1 mole of NH2, here it should be 4, right? Because in the question it was 4 here, right? So here it will be 1 mole of this is giving 2 mole. So 4 mole will give us 2 by 4, right? Okay. Why? What I am doing wrong here? What is wrong with me? I think I need some break, but I will not take that. Right? 1 mole of N2 will give you 2 mole of NH3. So 4 mole will give you 4 into 2 of NH3. That is 8 mole of NH3. Right? That means number of mole of NH3 is going to be 8. And here you will get mass of NH3 multiplied by 8 into molar mass of NH3. That is going to be 8 into 70. That is going to be your answer. Right? Okay? Yes. Okay? Okay, everybody? Okay. Wait a minute. Huh? We got 4 now. We got 4 mole na here. What was the question? Okay. That's funny thing. What to do? I'm speechless now, guys. I'm so speechless. What to do here? You guys are right. That's the problem. I am totally speechless now. Say, ma'am, what you are doing, ma'am? Putting the wrong values here, ma'am. I think the cold has, they say na, when your nose is not fine, when you have cold, then your brain stops working, right? I think that is happening with me, right? That was 2 mole here, right? So it was 1 mole will give us 2, this 2 mole will give us 4, right? 2 mole will give us 4, and then 4 mole, and you have this thing. Okay, now it's fine, right? Okay, yes, everybody? Yeah, these things happen, right? Okay. You know what you can learn from this? Ma'am, you need break ASAP. I know I need break, right? But I will not take, because only 1 to 2 topics we are left with. Only 2 topics we are left with. Why would I take break on that thing, na? Okay? Yes? Ma'am had dinners. No, I didn't had dinner. I didn't had dinner. Okay? So now let us see. Ma'am, drink H2O. Yes, I'm drinking H2O. Okay? Now the concept of limiting reagent is clear to you with my mistake. So I think that is more clear to you now. That okay, if you change one limiting reagent, it accidentally, just one mistake I did. Instead of N, instead of N2, I assumed N here, and the whole question was wrong. Right? Okay? So limiting reagent was very important, and this step is the most important step. Right? Which is your less number, which is your lower number. Right? Okay? Now, next one is percentage purity. Percentage purity is just a very simple formula. So always remember, if mass of element given in question is equals to purity plus impurity, mass of pure element plus the impurities, right? So that is the thing. Mass of the element that is given to you in the question, that is equals to 2 things, right? That is mass of pure element plus the impurities. Okay. Now, tell me one thing. If you want to calculate the percentage purity, what should be the formula? Purity you want to calculate, no? So that will be equals to, see, whatever percentage is always like you want to calculate. So for example, you have CO2. You want to calculate the percentage of carbon in this one. So you will calculate mass of carbon by mass of CO2 multiplied by 100. Isn't it the percentage? Same thing. Why to cram this formula? So same thing we are going to apply here. That here the mass of pure element. So purity we are calculating, that will be mass of pure element divided by total mass of element that is given in the question multiplied by 100. That is going to be the formula, right? Okay, that is going to be the formula. Is that clear to everybody here? Is that clear? Is that clear? Okay guys, is that clear to all of you? Now, next is if they ask you the percentage yield. So usually students get confused in these two things, right? If they ask you the percentage yield, right? Now, see one thing. This you will relate to this thing. For example, you have studied this much for your NEET exam, right? You know how much amount you will be able to remember. Tell me, why we are having these revision sessions? Because your mind is not able to remember anything, right? So, if this much you have studied, then maybe this much you can remember, right? That is why you need revision again and again and again, because your mind is like, I am forgetting everything, right? That means this much amount you are able to remember, this much so you are not able to remember. So, your efficiency will depend on how much yield you are giving, right? So same thing is like 0% I remember, right? Don't do this, yeah. Why 0%? You will remember nothing after this. Like, ma'am, yes. In the exam, we will go brainless in the exam. Now, percentage yield is the same thing. It tells you the percentage efficiency, how much you are able to produce, right? That you are expecting this much amount, but you are only getting this much amount. So what is the expectation versus reality? It is like expectation versus reality. Okay. So now you can write one thing here. One is your experimental value that is given in question, right? This will be experimentally calculated. They will not ask you go in the lab and calculate this, right? This will be given to you in the question. Other will be theoretical value, and that will be calculated by this. They will not assume, they will not give you this value either. They will not give you the value of theoretical value. They will not give you that. Just give me a second. They will not give you the theoretical value. This you calculated in question by stoichiometry. Stoichiometry, so you all know how to apply, right? After applying stoichiometry, you will get that value. It's the same, yeah, it's the same. Like I asked you to calculate the mass of O2, the volume of O2, I guess, or the particles of NH2 and all of these things. Now, mass of oxygen, or you say mass of carbon dioxide, you had calculated from the stoichiometry. Any question they can give you from stoichiometry for that particular compound, you will calculate the theoretical value. This will be given in the question. Then you will apply the formula of percentage yield here, right? Okay. Okay. Percentage yield. Now, see, in percentage yield, this is experimental value that you already, that means that is there in the question, right? That you have done in the lab, right? So now tell me one thing, that experimental value is the actual value. Here also what we did, what we want to calculate divided by what is there, right? The total amount. Now here, expectation versus reality will happen. We know that reality is this one, reality, and this is our expectation. expectation. So you can write here expectation versus reality. You must have seen the memes on that. This is expectation. No, this is reality. Right? This is reality. And this is expectation. Expectation. So it's like, ma'am, your mom visits your room. The expectation is something that you will study, but the reality is you are sleeping. So that is expectation versus reality. That means that will tell your efficiency. So your expectation is, so we want to seek the efficiency. So we want to see what is the reality here. Reality is the experimental value. Reality is the experimental value. And what we were assuming, right? And what is experimental? What is expectation? That is the theoretical value multiplied by 100. That is going to be the formula, right? Okay. So till here you can calculate. This will be given in the question. The next step is apply this formula. You will get the answer, right? Okay, guys. Okay, guys. Okay. Now, let us see what else we have. There is one more thing, that is minimum molecular mass. Now, I am just going to give you the formulas, okay? And these formulas are very, very important. Minimum molecular mass. Minimum molecular mass. They will just ask you the minimum molecular mass, that will be equals to atomic mass multiplied by atomicity. For example, for 2 elements, for 3 elements, for 4 elements, divided by percentage of that element multiplied by 100, right? Okay, so that is your minimum molecular mass. For example, they have given you C6H12O6. They have given you X percentage of carbon. So what is the atomic mass? That is 6 into 12 divided by X multiplied by 100. That is going to be the minimum molecular mass. Okay, that is going to be the minimum molecular mass. Okay, yes, yes, everybody understood, right? How to calculate this thing? Okay, simple. Now, next is empirical formula, right? What is empirical formula? What is empirical formula? Very, very simple, and high chances are they can ask you this question, right? Very simple. So empirical formula is the simplest whole number ratio. Is the simple whole number ratio of atoms. For example, you have C6H12O6. Now this is the molecular formula, right? If you talk about the empirical formula, that is CH2O. This is your empirical formula. This is your empirical formula, right? This is because it's a simple whole number ratio. You divided everything with 6 and you got this thing, right? You divided everything with 6, you got this thing. Now, there are two formulas that you need to remember. That molecular mass is equals to N into empirical mass. Second is molecular formula is equals to N into empirical formula, right? These are the two important formulas that you need to remember. Okay? What is this N? N is the thing that you divide it with. We know that here it is divided by 6 to get CH2O, right? So that is why N will become 6 here, right? N will become 6 here. So when you take out the common value, common number out of these atoms, that will become the value of N here, right? Okay. So now let us see this with the help of question, how to, how to solve this particular thing, right? So the question, let us take a good question here. Yes. Wait a minute. Just give me a second. Okay, let's take this thing here, right? Okay. An organic compound, they are saying that an organic compound has molar mass of 108 gram per mole, right? Now they are telling you that it has three atoms. C, H, N atoms are present in this ratio. C, H, N atoms. So what you need to do? Make a table, right? So I'm telling you that how to solve this question. In the first column, you will have the atoms. In the second column, you will have the mass. But I'll directly tell you what to do here, right? Don't make those many tables, okay? You'll get only confused after making so many tables, so many columns, sorry, right? So what you need to do here, in the first column, you will have the atoms. Always do this thing. Whenever you see the question of empirical formula, do this thing, right? This is your atoms. This will be your given mass by molar mass. Basically, these are going to be the moles. Given mass is in the percentage form, right? In the given mass will be given in the percentage form, right? So percentage divided by the molar mass, or you can say molar mass because we are talking about atoms, so that will be atomic mass, right? Then you write the simple whole number ratio. Simple whole number ratio, right? Okay, let us see that. Everybody, let us see that. Now, they have given you C, H and N. In the question, they have given you that carbon, hydrogen and nitrogen. I'm writing it here. Carbon, hydrogen and nitrogen are present in, what is the ratio? The ratio is given to be 9:1:3.5. 9:1:3.5. That is the question that is given to you, right? So, this is 9, this is 1 and this is 3.5, right? That is the atoms that are present here, right? The molar masses this are present in this by weight, right? By weight they have given you the ratio. Atomic mass of carbon is 12, hydrogen is 1, nitrogen is 7, right? Atomic mass is 7. Wait a minute. Atomic mass, no. Atomic mass is 14, right? Okay. Okay, got it till here? So what we have done here, percentage was given in the form of ratio to us. Sometimes it will be given as 20% of this, 30% of this, 40% of this. You can write 20, 30, 40. Sometimes it is given in the form of ratio. So in the form of ratio, it is 9:1:3.5. Carbon, hydrogen, nitrogen. So it is like this. Divided by the atomic mass, 12, 1 and 14. Right? Okay. Now, try to make the simple ratio here. So this will be 3 and this is 4. So it will be 3/4. It is 1 only. And this is, you can say that maybe 3.5 into 4. Right? Okay, so it will be 1/4. If you multiply all of these by 4, it will become multiply by 4, multiply by 4, multiply. I need to make a simple whole number ratio. Right, so that's why what we will do here is just bring this here 3/4. This is 1. This is 1/4. To make a simple whole number ratio, multiply this by 4, multiply this by 4, multiply all by 4. Okay, so it will be 3. This is 4 and this is 1. So can I say the formula will become C3H4N? This will be the formula. Yes, everybody. C3H4N. Simple, right? In a very simple manner, we have calculated. Just you need to know this thing. Atoms, moles is percentage, or maybe given mass. Maybe they will give you the mass. Maybe they will give you the ratio, right? Whatever they have given you. right? So if they have given you percentage, here you can write or mass or ratio, whatever they have given you, right? Okay, whatever they have given you. Now tell me, is this simple empirical form? Now understand one more thing. From here, this is the empirical formula. This is the empirical formula, right? If you want to calculate this from here, you will get the empirical formula as C3H4 and N. Now, what is the empirical mass? Always you will do. What is the empirical mass? That is 12 into 3 plus 4 plus 14. 36 plus 4 plus 14, that is 54 gram per mole. 54 will be the empirical mass, right? What is the molecular mass? What is the molecular mass? Molecular mass is 108. And I told you two formulas here. Molecular mass is equals to N into empirical mass. So just apply this formula here, right? Apply this formula here, and what you will get? This will be molecular mass is equals to N into empirical mass. Empirical mass is calculated to be 54. This is 108. So N will become equals to 108 by 54, that is 2. Right? We also know that molecular formula is equals to N into empirical formula. Empirical N is 2. Empirical formula is C3H4N. So here the answer will become C6H8N2. This is your molecular formula that they are asking you. Right? Okay? Yes. This is the molecular formula that they are asking you. Okay? Yes, everybody. C3H4N and this is 341. Right? And here empirical formula is 12 into 3 plus 4 plus 14. 40, 54, N is 2, and you can, okay. So this will become your answer. Okay? Yes, everybody? Everybody in the chat box, is that clear to everyone here or not? Is that clear to everyone here? So understand one thing, right? Yes, please don't chat in the class. Even the students are asking you, right? Even Shruti is saying that, what to do, ma'am, right? They are chit-chatting with each other, ma'am, right? They don't realize the value of knowledge. They don't realize this now, but they will realize this soon, right? Just you study now, they will realize this once their paper will not be clear. Now, then they will say, I too studied, I was there in Diksha Ma'am's class, but I was chit-chatting, right? You were not studying, right? Now, here we have one important thing. See, here they have given you the molar mass. What if they could have given you the vapor density? From vapor density, you can calculate molar mass, right? From vapor density is equals to molar mass by 2, right? What if they gave you vapor density as 54? What if they gave you vapor density as 54? So, molar mass will be 2 into vapor density. What if they have given not here molar mass, they have given the vapor density? What if they have given made the question difficult by not difficult, vapor density as 54? Then you know that the molar mass will be, then you know that the molar mass is equals to 2 into vapor density, that is 108, right? That is your molar mass. Okay? Yes, everybody in the chat box? Everybody? Yes, ma'am? Yes, ma'am. Yes, ma'am. Now, last is, I heard some noise. Just give me a second, okay. Now, let us see the percentage concentration terms. Concentration terms. So, for concentration terms, firstly, you need to know that in the concentration terms, firstly, we will talk about percentage composition, right? percentage, and this thing is exactly used in solution chapters, right? Percentage composition is always solute by solution, right? Always solute by solution. Solute is in less quantity, solvent is in more quantity, and solute plus solvent will become the solution, right? So always, if they are asking you the percentage composition, weight by weight, percentage, weight by volume percentage, volume by weight percentage, volume by volume percentage. Always remember one more thing here. Weight will be in, weight means W, will be in grams, volume, that means V, it is in milliliters. So you also need to remember the units in concentration terms, okay? So here it is weight of that thing I am taking, that you have a mixture of A plus B, right? You have a mixture of A plus B. A plus B is the mixture that you have. So depending upon that, I am calculating. If they are asking you for solution, not a mixture like that, they are asking for a solution with a solute and solvent. So always it will be solute by solvent. Okay, always it will be solute by solvent. Okay, so if you want to see that in that category, solute I represented by 2 and solvent is represented by 1. Okay, solvent is represented by 1. Always we will see this even in solution chapters. That's why now only I am denoting one digit for that. Solute is 2, solution is 1. Solute is 2, solution is 1. Right? So now here it is weight of solute divided by weight of overall solution. Right? So that means you can just simply write weight of solute by, so you can write weight of solute. Weight of solute is 2 divided by overall solution multiplied by 100. Now if you talk about weight by volume, that will be volume of solute divided by volume. See, weight by volume. So it is weight by solute divided by volume of solution in milliliters multiplied by 100. Right? If you talk about volume by weight, it is volume of solute divided by weight of solution multiplied by 100. Understood what I am doing? Always it is solute by solution, solute by solution, solute by solution. The trick is always will be solute by solution multiplied by 100. Right? And the weight is in grams, volume is in milliliter. If it is weight by weight, it is weight by weight. Weight by volume, weight by volume. Volume by weight, volume by weight. Last is volume by volume. Volume of solute divided by volume of solution multiplied by 100. Multiplied by 100. Okay, guys, let's ignore these people. We can't do anything. Right, let's focus here. Okay, let's focus here. Why to waste our time on them? Right, whenever there is some valuable thing in the chat box, ma'am, can you block him? Who is creating a mess here? Just name that person, spam that person, I'll block that. Right, because I am not able to directly see the chats of all the students here. So just tell me what is that student who is creating a mess of this class. Okay, just spam everyone and so that I can block that guy. Okay, great. Now this is your percentage composition, weight by weight, weight by volume, volume by weight, volume by volume. Now next thing is, if they are, how to decode, write it, how to decode this thing. How to decode this thing. How to decode this thing? For example, they have given you 50 or they have given you 10% of ethanol solution. That means solution. Ethanol solution means it is in the aqueous form. Now water is universal solvent. Right? Ethanol is the solute. Ethanol is the solute. Right? And solution means water is solvent. Water is the solvent. If they have not given anything, that means water is the solvent. Right? 10%. Now, for example, they have given you, weight by weight. Then what you can say? You can say that 10 gram of ethanol in 100 gram of water. 100 gram of water, right? If they give you weight by volume, that is 10% ethanol solution. Now can you tell me what can we decode from here? Right, very important things I am telling you. Right, what can we decode from here? 10% of ethanol solution. What can we decode from here? What can we decode? That means 10 gram of weight by volume. 10 gram of ethanol. 10 gram of ethanol in 100 always will be divided in the division. But here it is volume, so it will be 100. I have told you weight is in grams, volume is in milliliters. So 100 milliliter of water. Right? Okay? Okay, guys? Now, let us see, for example, they have given you, for example, here they have not given you weight by weight or weight by volume. Rather, they have given you, wait a minute. You need to fill these blanks, okay? They have given you volume by weight, okay? And here they have given you volume by volume. Now tell me what will be the decode of this thing. Volume by weight, that means volume, that means 10 milliliter. Okay, I'll just write it with some other pen. That means 10 milliliter. 10 milliliter. In the division you will have 100. But here it is weight, so it will be 100 gram of water. Right? Here they have given you volume by volume. Again it is 10, no? So it will be 10 milliliter. In the division also it's volume, so it will be 100 milliliter. Right? Okay? Understood? Understood everybody? Everybody in the chat box, are you able to understand this thing? Yes, everybody. Okay. Now, yes, it will be 100, not 1000. Okay. Now, for example, this percentage composition is not percentage, but they have asked you in ppm. ppm, right? In ppm, what will be the answer? In ppm, what will be the answer? In ppm, what will be the answer? Right? Here it is not percentage, it is ppm, right? It is ppm. ppm, it is also ppm, it is also ppm, it is also ppm. Can you tell me what is this ppm? What is this ppm? ppm means parts per million. Parts per million. So parts per million simply means that instead of 100 you have 10 raised to power 6. Here also multiply this by 10 raised to power 6. Everything else will be same. Everything else is same. Okay? Everything else is same. The difference is just multiply this by 10 raised to power 6 instead of 100. That's the only difference. So I'm making things easy for you so that you don't have to cram. Million is what? 10 raised to power 6, right? So here, for example, carbon dioxide is only 0.03% in our atmosphere. So instead of saying 0.03, we will try to write it in parts per million, that we have million, in million molecules, how many molecules of carbon dioxide you will have. Instead of saying in 100 molecules, you will have 0.03, right? Okay. When you have the solute is very less, then we use parts per million, right? Now, next thing is fraction. Now, basically, there are very famous thing is mole fraction only. But for example, what is mass fraction? If they ask you the mass fraction, what is mass fraction? Mass fraction is mass of that thing, whatever you are saying, mass fraction of, let us say, 1. Mass fraction of 1. So that is weight of 1 divided by weight of 1 plus weight of 2. Right? That is your mass fraction. If you say volume fraction, this I think you have not even like used anywhere. Volume fraction of 1, that will be volume of 1 by volume of 1 plus volume of 2. And here units will not matter because eventually they will cancel out. Gram, gram, kilogram, kilogram. cancel out each other. So these are fractions are going to be unitless, right? These fractions are going to be unitless. Third one and very important is mole fraction. That is there in your syllabus, right? Mole fraction. By chance they ask you mass fraction, no? Get confused, ma'am. What is this? Nothing. It's very simple, right? Mole fraction means number of moles. So if they are saying mole fraction of 1, so it will be number of moles of 1 plus total number of moles. If they say mole fraction of 2, that will be number of moles of 2 divided by total number of moles. And this is represented by this symbol. This is called chi. Okay, students say this is chi. It is just like x. Okay, so this is chi of, because we are calculating for 1. Here this is for chi of 2. And always remember the mole fraction of all the components. Mole fraction of 1, mole fraction of so, like we don't know how many components we have, that will be equals to unity. Mole fraction of all the components in that solution is going to be unity, right? These things are very, very useful, right? They will be applied in your physical chemistry, right? So mole fraction of all the components that are present in that mixture is going to be unity, right? And remember one more thing here, that these mole fractions are unitless. They don't have units, because units are going to cancel each other. Mole will cancel, volume will cancel, weight will cancel, right? Okay, that is your mole fraction. Next is two very important things. That is, first is, what is molality? Represented by small m. Here the units are going to play a very important role. This is number of moles in solute, or you can say number of moles of solute divided by molality. In this case, remember Varun. How to remember that? V for volume, R for molarity. Because the difference between molality and rity is just, here you have R and here you have L. So when you have R, you have volume, right? You can also remember this by Virat Kohli, right? I have nothing special with Varun, okay? So you can also use Virat. So number of moles of solute divided by, this is mass or weight of solvent, right? So here this will be number of moles, simply they will to cancel each other, but mass of solvent will be in kilograms, right? Mass of solvent will be in kilograms. Now next thing is molarity. So the only difference, this is capital M, right? This is molarity, this is molality, right? That is the difference. So that is equals to number of moles of solute divided by molarity will have volume, right? So that is volume of, because students tend to get confused, they just confuse these two statements with each other, right? So volume of, here we had solvent, here we will have solution. Virat Kohli is everyone's favorite, no? So solution also have both solute and solvent, right? So here volume of solution, and this will be in liters. Very, very important. That's why I'm mentioning this, very, very important, right? This is liters and this is kilograms, right? This is liters and that is kilograms. Okay, Virat Kohli. Chalo, I'll write Virat here. Why to give like that much importance to Varun Dhawan? Let's write Virat. I think yesterday only he made a like something happened in cricket. I know that. Maybe some century or something. You know, something happened yesterday. No, what happened? I think that was like something happened. I don't know. I won't say because I don't know. Right? Otherwise, so you know my cricket knowledge. No, I am not a cricket fan, but these kind of things, so we all know, na? What happened? Tell me. You can increase my knowledge on that. I would love to increase my knowledge. Now, next is strength. Next is strength. Now, strength is same as molality only, right? Okay. So, it is same as molarity only. So, it is basically, instead of number of moles of solute, just write weight of solute, right? So, it is weight of solute. See guys, in chemistry, weight and mass are same things only. In physics, it is different. I know. In physics, you'll say, ma'am, weight is, ma'am, when we multiply this with, ma'am, weight is equals to mg, ma'am, mass into gravity, ma'am. What you are saying, weight and mass are same. But in chemistry, see, these we are talking about very small, tiny particles, right? Atoms and molecules. So in atoms and molecules, how much gravity, right? That is why it is mass and weight both are same. So anywhere if I am writing mass or weight, that is the same thing, right? So weight or mass of solute divided by volume of solution. And this again in liters, right? That is your strength. Okay, that is your strength. Okay. Now I am going to write down some very, very important relations here, right? Very, very important relations here. First is strength is equals to molarity multiplied by mass of solute, right? Molarity, if you multiply molarity with mass of solute, we know that molarity is what? Molarity is number of moles of solute. Number of moles of solute is what? If you want to calculate this like here, you can say that number of moles of solute is weight of solute divided by molar mass of solute multiplied by weight of solvent. If it is given in grams, then it will be 1000. Now here, here all of them are in grams. This is also in gram, this is also in gram, right? That is why it is multiplied by 1000. Here I can write it as weight by molar, volume of solution. If it is in milliliters, then it will be multiplied by 1000, right? Okay. These formulas should be on your tips. Okay, guys. Okay, everybody. Now, one more question, one more formula here, right? Molarity is in weight by weight percentage, right? Okay. So 10 into density into weight by weight percentage of solute divided by, these are the direct relations, okay? Molar mass of solute. For example, they have given you weight by weight percentage of solute. They have given you molar mass. They have given you density. You can easily calculate the molarity from there, right? But I would not advise you to use these direct formulas because I myself don't like to use them, right? But sometimes to make the question, because in competitive exams, we have less time. So we need to use these formulas, right? Okay. Okay, guys. One more formula and the last one of today's class is molality and molarity relation, right? 1000 into molarity divided by 1000 into density minus molarity into, I know now this is like you must be finding it tough, but you can easily write it down as 1000 into capital M divided by 1000 into density minus molar mass of solute multiplied by molarity, right? You can easily write these things here, right? And this also can be written as, this is 10 into density 10 into density, or you can just write 10 into weight by weight percentage of solute. 2 means solute. 2 means solute. Just, we don't have space, so you can write it like that. Okay, you can write it like that. Okay, understood? Yes, everybody? Yes, organic chemistry is completed. Okay, guys, everybody in the chat box, tell me, is there any problem in today's lecture? Is there any problem in today's lecture? Ran too fast. Thank you so much, ma'am, for teaching us continuously for 3 hours out not taking break. Thank you so much for being here, like without any break. You were here, and for understanding my situation that there was something wrong with the OBS, and that's why there was video lag. And that's why I love you all so much, because you guys adjust with me, and that's the best students. You are my like best students, because you are not throwing tantrums here, right? You are appreciating that, yes, Vedantu NEET English is giving you like really good content for totally free of cost. Now, I know that your question will be, ma'am, is this chapter completed? So let's see. I told you we will do law of chemical combination, mole concept, stoichiometry, limiting reagent, percentage, yield and purity, empirical formula, concentration terms. All done and dusted. Right? Okay. Right, everybody? Yes, we have completed this chapter. Right? And there is something really, really amazing waiting for you all. Right? Really, really amazing. 28th May at 7 p.m. Right? So tomorrow at 7 p.m. you will go to the live section. You will see that live already there. Go and hit the like button now, and I can't wait to give you that surprise, right? Because that was highly demanded by students, and that is the need of this hour, right? So I am so excited for that. So everybody, tomorrow at 7 p.m. I'll see you all on this channel live, and we will see what is the amazing surprise for your NEET 2025 preparation, because we are just 5 months away from it, right? So we actually need that, right? So that is your need, and your need is always granted here, right? Okay, so are you all also very excited for that? Yes, if you are excited for that, then green hearts in the spam green hearts in the chat box if you are very, very excited for that, right? And I know you all must be thinking that, ma'am, where is the practice, ma'am? We want a different practice session for these questions as well. So don't worry about that. Firstly, let us do what we are doing now. I have told you already that what are the type of questions that will be asked to you. Different practice sessions also I will take. Don't worry about that. When Diksha ma'am is here, then why fear, right? Okay. Yes, now I'll be waiting for your lovely comments, because I was down with fever, I had cold, you can see from my voice as well, right? I was not fine, the OBS was not working, still I had all the excuses to say that I don't want to take this class, but I was like, I'll take some medicine, but I will be here for my students, right? So I want to see your comments. I want you to post it in your WhatsApp status, on your Telegram, on your Instagram. You can also follow me on the Telegram, Diksha __𝐤𝐤 𝐻𝐿 official. And you can also tag me on the Instagram, that is Diksha ___𝐻𝐿. You can tag me, show my video, and whatever homework. If you have made any notes, you can just click that photo and tag me on the Instagram, right? And also I have my Telegram group where you can also text me, and you can also text your notes or images, any doubts that you have, right? Okay, yes. Okay. Yes, name, something really amazing is coming for you tomorrow, right? So I'll see you at 28th of November, 7 p.m. Okay, bye. Thank you so much. And don't forget to comment down, like the video, and share this with your friends. I am seriously waiting for your lovely comments. Just fill this comment section with big comments, right? Okay, bye. Lots of love. Bye.